There we go. Let's see if that did it. Can you see or hear me? Let me know. Are we on? Excellent. All right. Beautiful. Thank you, Lenina and Claire Burr. Welcome everybody back to Paleontologizing. Welcome to our final day of streaming out here in eastern Utah. Broadcasting a live dinosaur dig, as I often do during, the summer. It's not even the summer anymore. It's going to be October in a few days. And I've been out here for a week and a half, something like that so far, digging up ankylosaurs here at Laurie's site in the early Cretaceous Cedar Mountain Formation, out here in eastern Utah, working with the Prehistoric Museum out of the town of Price, Utah. And I wanted to start today's stream just a little bit early because we've got big storm clouds gathering on the horizon, and that could mean we have to end the stream early if those hit us. So we'll see. Live broadcast, anything can happen. Today's stream might be cut short. We might end up with a lot of rain. I've been hearing some thunder as well. So we'll see. I don't know how long we'll have. Could be an hour or two. Could be less. Or the thing might miss us entirely. It might, if it drifts this way, it might just barely scrape by without hitting us. So we'll see. Stay tuned. If it's your first time watching, welcome to Paleontologizing. Let me introduce myself. My name is Danny Anduza, and I'm a dinosaur paleontologist, although I'm hopefully branching out into some other areas of vertebrates. Anyway, I hope you're already aware that a paleontologist studies fossils. I've mostly focused on dinosaur fossils in particular. Dinosaurs are what I study, what I publish on in the scientific literature, and what we're digging up here out in eastern Utah with the Prehistoric Museum. And, here comes curator and expedition lead Josh Lively right there, who just returned from town with some more water for the crew, keeping us from dying of thirst.
Big gulp.
There you go. The essentials of desert survival.
Oh, yeah.
How was the drive?
Oh, it was fine.
Nice.
Easy, just 55 more gallons of water.
Excellent. Yeah.
And a lot are on their way.
I should have picked up a big funnel. Yeah. But, so we'll see how long this stream goes today.
I'm thinking I'm probably going to get out of here in, like 45 minutes at the most.
Okay, yeah. If you want to skip the marine reptile chat, we can do that, because I don't want you to get stuck out on the road or anything.
Oh, well, I'm not too worried about getting stuck. I just don't want to get wet.
Yeah, fair, yeah. Do you want to talk briefly about marine reptiles, or do you want to just pack up and get ready to go?
No, let's have a quick chat about marine reptiles.
That'd be cool, yeah. So for all you folks who were early, well, you're in for a treat. We had to cut our chat short yesterday because we had more weather coming in, but let me grab those books. And so we were talking about marine reptiles. We got through the Jurassic, and we were about to talk about the Cretaceous and Josh's specialty, mosasaurs. And we had to postpone that until today because of weather. So,
and we'll probably make this discussion of mosasaurs quick because of weather today.
Exactly, yeah.
It's wild. But it's monsoon season in Utah.
Seems a little late this year.
Yeah, it's been highly variable the last few years, I think. Sometimes it comes early, sometimes it comes late, sometimes it doesn't come at all.
Yeah, that's climate change for you.
Yeah.
Oh boy. But so you lucky folks who were here at the beginning of stream get to be here for this. So already edited yesterday's interview into a podcast format. Thank you so much, Claire. I appreciate that. That is awesome. Cool. Well, we're gonna have a continuation now. So I've got these books, which I was showing off yesterday, which are both new. I'm starting to get more into marine reptiles because I'm starting to get into turtles, dermacheliids in particular. Dermacheliids? Tomato, potato.
Yeah, I think I'm thinking about which syllable to put the right emphasis.
Right. Yeah. It doesn't really. As long as people know what you're talking about, it doesn't really matter.
Leatherbacks. You know.
Yeah.
Yeah, it's a more accessible term anyway.
Exactly. Yeah. Let's see. Do you want to sit in the same place we were sitting yesterday? And
Sure, let's do it.
for the sake of continuity,
Oh,
I guess.
yeah.
Oh, and I left my dry erase markers here. I didn't realize.
Yeah, we covered them up. Made
Thank
sure
you.
they didn't. Well, they got a little wet, but
Hopefully they're. No, they'll still be good. I'm sure. Make sure I bring those with me. I figure we won't actually need the whiteboard, so.
no, I can gesture, and we have books. So
Exactly. Yeah.
those will be good visual aids.
So, just as a quick recap from yesterday, marine reptiles they're not actually like an evolutionary group. Through a group of convenience, they're reptiles that live in the ocean. So today that's everything from, well shoot, I think in here we've got one of those diagrams, right? Or a picture with some of those where it's
I
like,
know what you're talking about.
here's
It's
your
one of them.
modern marine reptile. There we go. Yeah, our,
Yeah, nice.
so we've got, going clockwise from the upper left, sea snakes, sea turtles, crocodilians, and marine iguanas are our only marine reptile groups around today. But marine reptiles used to be the big thing during the Mesozoic. So
Yeah.
like every big vertebrate animal, except I guess for fishes, non-tetrapod fishes,
Yeah.
they were all marine reptiles. This is before the evolution of marine mammals and everything. So back in the day,
I can't move it.
no, we're good. We're good. Yeah, so we went through the Triassic and the Jurassic, the rise of groups like ichthyosaurs and plesiosaurs, and yeah. But I know you're excited to talk about mosasaurs. Or
Oh,
at
yeah.
least that's your specialty.
For sure.
And we've got a mosasaur on the cover of this
On
book
the cover
right here.
right there.
Yeah, they're in many ways kind of some of the most charismatic of the marine reptiles. What is a mosasaur, Josh?
Yeah, so a mosasaur is, getting into the nitty gritty, there's a great paper by Mike Caldwell that asks the question, what, if anything, is a mosasaur?
What do you mean, what, if anything? Oh, like maybe they're not a monophyletic group?
Exactly.
Oh,
he was
okay.
he was really, putting that out there, really the last couple of decades. Really, trying to figure out not only where do mosasaurs fit within the family tree of lizards. So step one, they are lizards.
Okay.
But then step two, do they form kind of a natural evolutionary group?
Right.
And
And when you say natural evolutionary group, what does that mean for the viewers at home?
So a clade. So what that means for you guys, think about cats. Cats are all more closely, everything that we consider a cat is more closely related to one another than it is to any other group.
Mm-hmm. And they all come from a common ancestor.
Exactly. And that's, so when you take that related group and chase it back through evolutionary time, including not just the modern ones, but all the fossil relatives, like you said, that one common ancestor. And with mosasaurs, we know that they're lizards. Mm-hmm. In fact, the study of mosasaurs goes all the way back to the 1700s when it first was discovered.
Cuvier.
And Cuvier, that when they found this big thing in the Netherlands, they said, what is it?
These huge jaws with these big nasty teeth.
Really huge jaws. Folks said, is it a big croc or is it the bones of a whale? Mm-hmm. What is it? The background there, though, is that in the 1700s, there was no concept of extinction.
Right.
Even the scientific world and Christianity, to an extent, and that species were immutable.
Yeah.
Is what they would call.
Divinely created, and why would God ever let any of these things go extinct? Like, the idea was blasphemous, that part of God's perfect creation could ever blink out of existence.
Yeah, so long story short, the revolutionary armies of France captured this fossil and took it back to Paris. Mm-hmm. There's a whole story just behind that, but looking at the clouds, we don't have time for that. And so this guy Cuvier, who was one of the first comparative anatomists, he looked at a lot of modern skeletons and comparing and contrasting those skeletons. And so looking at this thing, he recognized, no, it's not any of those other groups. This thing is a lizard.
Right.
And a lizard that is way bigger than anything that's around today. And so that, along with a few other fossil organisms that Cuvier was working on and identifying, based on their anatomical similarities, that he said, oh, there are these things that no longer exist. And so that's how the concept of extinction was born. In the grand scheme of science, really going back only to the early 1800s.
Nuts. Is it like in science and models of how it works for longer than we've had the concept of extinction as an accepted scientific idea? It's wild.
About continents moving around. That's the 1960s.
Yeah.
So things that we take for granted, those of us in the geosciences, are relatively young.
Yeah.
But yeah. So with mosasaurs, the idea was that they always formed one of those natural evolutionary groups with one common ancestor. They're these big marine lizards, and the debate where they fit in within the lizard family tree has always been, and really is to this day even, depending on which research group you align with, are they more closely related to things like varanids, so monitor lizards, picture the Komodo dragon, or are they more closely related to snakes? I think one of these books has that diagram in there.
Is it here?
I think it might be the other book.
The other one? Yeah. You can pitch through if you want.
Poses. So essentially, are they... regardless, they're lizards because snakes originate from lizards. But are they, things like monitor lizards, which they do look a lot like. They look like Komodo dragons.
Komodo dragon right there in the picture, yeah. It's also a Gila monster. Is that a proposed relative of...
It's kind of a closely related group.
Yeah.
But yeah, is that where they fit in, or do they kind of fall in line more with snakes? That's the big question. And some folks, of course, will tell you, oh, there's no debate. It is this. In fact, most folks that are working on the problem of what is a mosasaur would say, oh, no, my idea is right. Myself, I work on later mosasaurs. Just flipping through this book, saying, what can I show you? I work on later mosasaurs, and they tend... once they're fully aquatic, fully marine.
It's a decent mosasaurus.
Oh, yeah. Kind of give you an idea of what these look like. And you'll notice they're if you were on the stream yesterday, or if you go back and watch the video, they're pretty convergent with some of these other marine reptiles.
Right, yeah.
Very, very dolphin-like, very toothy, but yeah, they're marine lizards. And one thing that we're learning, so there are multiple groups of mosasaurs. There are at least, or traditionally, 4 main subgroups of mosasaurs. And what's really is that the earliest 2 of those groups have very lizard-like legs. The implication there is that mosasaurs evolve an aquatic lifestyle multiple times.
Oh, boy.
Which does pose that question.
Yeah.
Are they a monophyletic? Are they a natural evolutionary group? Or are we talking about cats, dogs, bears, and pigs here? Now, I think regardless, they're probably very closely related. Maybe anguomorph lizards. But my answer when anyone ever says, oh, what do you think? I say we need more fossils to really be able to tell that story. And some of those early members of those different groups of mosasaurs, let's see, Dallosaurus I think was named 2005. Cerobosaurus, which is an early plioplatycarpine, was named out of southern Utah, and it's North America's oldest mosasaur. Just named in 2023, I think.
Shoot, very recently.
So very recent. So actually, that one they didn't have any limb material with it. I know it has a lizard-like limb because we found a second specimen, and it has a humerus.
Nice.
Has an upper arm bone.
Not described yet?
Not yet.
All right. That's exciting.
It's prepped out, and we've...
You heard it here first.
Yeah, exactly. We've CT scanned some of it, but actually, this is hearing it at first. I do have part of a humerus, but yeah, I've CT scanned it. It'd be a good student project. But yeah, so mosasaurs, and it doesn't surprise me because when you look at the mosasaur flipper, we might have a diagram in here.
There should be one in there, or maybe in here. I'll look through at the same time.
Those major groups of mosasaurs all, for lack of a better phrase, build their flipper differently. So mosasaurs were tied together because they are lizards that converge with other marine reptiles, and having a flipper or paddle is what a lot of people call them. I like flippers because I watched the show Flipper when I was a little kid. They kind of, they all have the similarities with other marine reptiles and other marine organisms in general, like whales, of evolving more phalanges, so the bones in the finger. The fingers get long, form that flipper. But yeah, the different groups of mosasaurs do that in different ways.
Interesting. So all of them evolved more phalanges, so more bones within the fingers than you typically have, right?
Yeah, but then the bones more proximal to that all look a little different.
Interesting.
So they're clearly on their own evolutionary trajectories, and traditionally, all the features across the skeleton. It pulls mosasaurs as they are. We're mostly using all of those highly adapted aquatic animals. You're not including all the early ones that don't look like the later ones.
Right.
So you're at the very least getting convergences potentially between those different groups of mosasaurs, which I think is one reason why they always pop out as a natural evolutionary group. But it's just wild to me to think that during, and it makes a bit of sense, right around the time the ichthyosaurs go extinct in the late Cretaceous, sea levels are at their highest. Global temperatures are at their warmest, really any time in, complex life's history, I would argue. Multiple groups of lizards take a dive into the deep end, into the seaways, and it's a really cool thing. And so I worked on one of the main groups of mosasaurs called mosasaurines, and they were really interesting to me because unlike some of the other groups, they were all relatively diverse. We're talking by the end of the Cretaceous, probably upwards of, that we know of, maybe 30-ish, 40-ish coeval species globally. I haven't added those numbers up because new ones are getting named from Morocco every year now. But, this is what a mosasaur skull looks like. So the one group that I worked on diversified into, not just these big toothy things that eat, anything in sight in the oceans. There were specialists. There were also some generalists like Pronathodon, one that was very much a kind of a garbage can. You'll find stomach contents that include fish, turtles, other mosasaurs, and its teeth kind of look like these big railroad spikes, almost kind of reminiscent. All purpose to just bust through anything. Kind of reminiscent of what Tyrannosaurus other tyrannosaurs.
So really thick teeth in cross-section?
Really thick. A potential close relative of it. Called globidens. I think that's a globidens. It looks like one.
That's what it says,
Globidens. Has very rounded teeth. And what do you find in its guts? Sure enough, shells. So things like ammonites, inoceramids, so these big clams. So they were shell specialists. And so that's one group that was hanging out. Mosasaurus and some of the early forms, early species of Mosasaurus seemed to be fish specialists. Had very recurved, sharp teeth that and fish have been found in their guts.
Are they kind of conical? Maybe even with like fluting, like you see on croc teeth?
Some of them, cool. Especially the later ones. And then you had all this diversity within this one group. And unlike other things, I know I'm sure you guys have probably talked about the debate about what dinosaur diversity is doing towards the end of the late Cretaceous.
I'm not convinced it's declining much, but
I'm not either. I think it's a sampling issue. with mosasaurs, based on the sampling that we have, no doubt about it, the last second before the asteroid hits, they are at their peak diversity. Like, just all the way up. And
it's the golden age of mosasaurs right up until extinction.
Exactly, yeah. And what's wild to me, and, you know, we won't have time to get into it, but there are so many, you know, within their relatively short, maybe 30 million year evolutionary history, you know, they go from lizards to something extremely whale-like, very quick. And it really shows kind of the really interesting things to me about evolution, where you do have these convergences and drivers, you know, that are you know, the selective pressures that are basically driving evolution. You know, you might have seen in one of the photos, you can see it better actually in that one, not photo, but life reconstruction.
This one here?
The Mosasaurus. The big,
in the back, yeah.
Was that one of
I think
mine?
it's in the back of
my
here.
book. I don't know.
This one here?
Yeah, that one.
Like we were showing earlier?
Yeah. So, you ever look at a lizard's face? The nostrils are at the end of the snout.
Yeah.
Nostrils are up here.
Retracted,
Yeah. So you're seeing, well, essentially a lizard blowhole there.
Right. Yeah.
And they're doing it in a similar way where whales telescope their bones over one another. Mosasaurs are doing the same thing.
Interesting.
And I've seen some unpublished mosasaurs where that's very extreme, where some of the bones at the front of the snout are almost touching the back of the skull. They're at least getting close to that.
Yeah.
Which is totally different than other lizards, which have a very mobile, what we call kinetic skull. And especially if you think about snakes, you know, being able to, you know, eat something bigger than their face. Mosasaurs lock up their skulls from a very kinetic and that's, you know, one of their adaptations that they have.
Very cool. Such a neat group of animals.
They're really cool.
And it's wild just how widespread they become too. Have they been found on every continent?
Every continent.
Including Australia? Because I was going through, I know they're from Antarctica, North America, Europe, Asia.
I guess if you... Oh, shit. Yes, there is one mosasaur vertebra at least. I don't know I can't remember if he ever published it. Ernie Lundelius, who is a emeritus professor at the University of Texas at Austin. He's 97, I think. While I was still a grad student, up until he was about age 90, he was still coming into the lab every you know, having coffee with him. It was great. But he was in Australia looking at Pleistocene, looking at Ice Age cave deposits, looking for fossils there. Then he took a trip to the west coast of Australia at one point, and he found a mosasaur vertebra. So, yes, technically, I have no idea if that was ever published. I think it might have been, but yeah. So, and especially too, if you were to lump New Zealand in with Australia, you know, Oceania, then definitely, because lots of mosasaurs from New Zealand.
Nice.
So yeah, pretty much every corner of the globe.
So where you're from, Alabama, also famous. Well, I don't know if it's famous, but there are a lot of mosasaur fossils from.
There are,
Alabama. Is it like in terms of state rankings? If you were to tally up all the mosasaur specimens from each U.S. state, Alabama's like second, right?
It would be up there
after Kansas.
After Kansas,
yeah.
I'd say Kansas, Alabama for sure. I mean, there's some very early mosasaur collections and other fossils from Alabama from the Field Museum back in the day.
Nice.
But yeah, I would say I'd put Alabama up there. Maybe right behind Kansas.
California is up there too. Which I was surprised.
California's pretty good. Yeah.
And lots of stuff from the Central Valley, Fresno County. Yeah.
So mosasaurs definitely a big deal in my home state. Even though our state fossil is the early whale,
and surprisingly mosasaur-like.
Very mosasaur-like. It's you know, convergences. It's crazy.
Yeah. So well, cool. How are we doing on weather? Because I don't want to get us trapped by the storm coming in.
I'm wondering.
If you want to look at the weather radar real quick.
Yeah. I'll pull out my phone because I do have internet with you.
Yeah.
But yeah, you know, there's one of the things, and I hinted at this yesterday, but you know, just in case you weren't watching the chat, We are right on the edge of rain. The worst of it is to the east of us, but I think we'll be fine. We might not even y'all might not have to tear down tarps.
That'd be nice, yeah.
Yeah,
Shoot.
we'll see what this is gonna look like, but it's sort of dissipating and getting worse to the east instead. But yeah, so one thing that's really great about mosasaurs and why I enjoy studying them is just how big of a sample size there is.
Right.
I mean, there are just literally thousands of mosasaur individuals in museum collections. KU, the Smithsonian, Yale Peabody, the American Museum of Natural History.
Yeah.
Lots and lots of mosasaurs.
Berkeley too. Yeah.
Berkeley,
Good
for
number
sure.
at Berkeley, yeah.
So yeah, the you can really start to address questions of evolutionary questions, questions of variation and variability in within a species. Because I've got some interesting things, some ink spilled but not submitted into the literature yet, that I kind of started thinking about during my dissertation, where mosasaurs are actually, at least the group of mosasaurs I was working on, might be a really interesting model for understanding evolutionary dynamics more broadly.
Yeah, yeah.
More on that to come.
That's really cool. And this goes to something that I talk about on stream all the time, that we as paleontologists, we're interested in a lot of these different animals, not just because they're big and cool and toothy or whatever, but they can help us tell really interesting evolutionary stories. Like, we can gain important insights about the history of life on Earth, and mosasaurs are they're a really good example of that.
Yeah, and one reason why I study turtles and mosasaurs, mosasaurs, are only in the late Cretaceous, really. Yeah. And then maybe some early guys in the, we'll see. How far back they go. And then turtles also from the late Cretaceous. It's an interesting study system for me because we've talked about this, where paleontology is really, to me, the past is the key to the present and the future. And working in the late Cretaceous, it's a very different system where you have a hothouse climate.
Right.
And if you can better understand evolutionary dynamics and ecology in a hothouse climate, maybe we can better understand what the future of our planet might hold.
Right. With the climate changing right now, humans causing all this warming.
Yeah. I mean, there are definitely time periods where you can look at very rapid warming, like the end of the Paleocene, beginning of the Eocene. We call that the PETM, where temperature spikes really quickly. Yeah. But kind of having that other end member too, where you have animals originating and evolving in a hothouse climate. How different is that from things in an icehouse world like we are, at least for now and today?
For the time being.
Yeah, so, I just think it's an interesting system. So
it definitely is.
That's what kind of drives my interest in the late Cretaceous.
Yeah.
Here in the on there, and I said, that's awesome. Yeah. You can actually see it in a few museums. Let's see, BYU is where the actual fossil is. See the John Wesley Powell Museum
in Green River,
Green River, Utah.
Nice.
And they've got a skull over in Cedar Edge, Colorado, where it was found, kind of southeast of Grand Junction. But yeah, back in the 70s, BYU was digging in western Colorado. I think they were on a dig in the Morrison, digging up dinosaurs. And this guy finds a something on the hillside.
Hang on, I think we might choose. Okay, I think we're mostly back. It's a little jittery right now. Sometimes the satellite dish gets like that. Yeah. Sorry to interrupt.
No, you're good.
Yeah.
But it was discovered in, I think, 75, and the fellow let his teacher know that, there's this thing that I found, these fossil bones. And teacher connected with the BYU folks somehow, and they came, checked it out, and dug up this specimen. And then Fast forward, it ends up being prepared at BYU and was the subject of a master's thesis. A student did their master's thesis on it, and then ultimately published it as a species of Prognathodon, which made sense. A lot of similarities between it and Prognathodon.
Yeah.
It was Prognathodon Statmani, which was honoring I think he was a preparator, Ken Statman at BYU.
Nice.
And so then, fast forward to my time at Texas when I was doing a dissertation. I was on a big long road trip doing field work and collections work from Austin all the way to Edmonton, Alberta, and hitting collections everywhere in between. And I knew about this specimen. I stopped in at BYU because I thought it might be relevant to my project. And Rod Sheets, who manages the collections there, said, "Yeah, we've actually prepared more bones from this mosasaur since it was originally described, and those might be important." One of the more important bones for mosasaurologists is the quadrate, which is a bone in the ear region of the animal. A lot of features on it that are potentially relevant to understand. And the quadrate was similar to Prognathodon, not quite though. It was kind of a perfect sort of intermediate between earlier Mosasaur. So I said, "Wow, this is really cool. Do you think any of your students are chomping at the bit to do this?" And Rod said, "No, go for it. Write it up." And so I had 2 days allotted to my time in Provo. I wrote a dissertation chapter in 2 days, or at least collected all the data I needed for it. And I ran it in one of my phylogenetic analyses, and trying to figure out the pattern of the mosasaur family tree. And sure enough, it bounced around a bunch, depending on the statistical analysis I was doing.
Okay.
Sometimes it would be closely related to Prognathodon, but not within the group Prognathodon. But then it would bounce around to a couple other positions as well. So because of and the differences in the anatomy from Prognathodon, it seemed like a good reason to give it a different genus name, and so I went with Gnathomortis, which is kind of an abomination because it combines Greek and Latin.
That happens a lot.
I asked someone what they thought about it, and they said, "Yeah, it'll be fine. If somebody really hates it, that's up to your reviewers." And they let it go through, so it's fine. But yeah, this is one of the first.
What does the name mean?
So it means jaws of death. Gnathos and mortis, jaws of death.
Yeah.
The reason I did that is because mosasaurines, they get big, but this is one of the first members of that group of mosasaurs to get truly large, over 1 meter skull length. The skull length on that animal is over a little bit over 4 feet long.
Wow.
Yeah, based on the lower jaws.
Yeah.
And also it's got this big area on the lower jaw, this massive excavation as a muscle attachment. So mosasaurs are often, reconstructed as these fairly sleek things looking very Komodo dragon-like. But I really want to work with some paleo artists because Gnathomortis and Prognathodon specifically, they've got the same shelf for these large muscles that you see on collared lizards.
Oh.
So if you've ever seen a collared lizard, they've got these big, massive jowls.
Yeah.
We're reconstructing our Prognathodon and Gnathomortis incorrectly if we don't give them those big, massive jowls.
Interesting.
Because then they've got the corresponding shelf on the squamosal bone up here too. So they've got these massive muscles, which are in collared lizards and other things that have them, tied to a stronger bite force.
Right.
The question I always get, if it goes in the chat, no, I haven't calculated what that bite force is. But it really shows that that allows these animals to break through tougher prey items, whether they're turtles or the bones of another mosasaur, but also to consume larger prey items.
Right.
So not just tougher, but larger prey items. So Nathomortis kind of shows that pattern, and it was a fun one to work on. I published that back in 2020 during COVID.
Nice.
Came out, I think, maybe 2 or 3 weeks after I got this job, which was kind of fun.
That's awesome. Makes you look really good when you walk onto the job and here's this exciting new animal that I've just published.
Yeah, I need to get a few more of those out soon.
Yeah. Nice. Well, I know the feeling.
So they're still impressed.
Yeah. Nice. Cool. Well,
are there any questions?
We did have a couple of questions, not about mosasaurs, but
because it's only 2:35.
Okay,
I've got a few minutes.
Yeah.
And I think we're good on weather.
Yeah, it looks like it's maybe not going to hit us.
It fell apart.
Yeah.
So
awesome.
Great. Yeah, I think we can.
Yeah.
Kind of chill out and.
Dr. Terminator asks, let's see, how are some plesiosaurs able to make it far inland with fresh water as overall ocean-going animals, like fluvionectes from Dinosaur Park?
Right.
Yeah.
Physiologically, you've got to be adapted for that to some extent, because if you're marine adapted, you've got salt glands.
Yeah.
But you think about it today, and saltwater crocodiles are able to do it. And you do kind of wonder, because we got lucky with that animal up in Dinosaur Park where it was discovered. Positional environment, even though it's a river versus an ocean. But you do kind of wonder how doesn't seem to happen in marine turtle, with one exception that'll be coming soon. But it happens with plesiosaurs. Happens in at least one mosasaur. Blanking on the name right now. But
the one that was found in the Hell Creek, or a different one?
Well, the one in the Hell Creek is that fluvial.
Right,
I reviewed that paper.
Interesting. Okay.
It's kind of on the edge, so
yeah.
I do kind of wonder, especially given the taphonomy of the specimen, is it truly living in a river? I don't know.
Okay.
But there are some very coastal facies of the Hell Creek, so it's possible.
Yeah.
Could have been washed in by a hurricane. Going up the interior seaway.
Sure.
But maybe it was. Who knows? I don't know. But there was one from Europe, and I'm blanking on what it's called, that was found in a fluvial deposit.
Yeah.
I think there are probably more out there, and it definitely is a story of some plasticity in their physiology.
Gotcha.
To be able to handle that.
Pretty cool. Yeah. Another question from the same viewer: what side of the mosasaur debate are you on? More closely related to monitor lizards or snakes?
I don't think we have enough data to say.
Interesting. Okay.
So get a lot of entertainment watching the two sides argue about it. I mean,
what would you like to help settle that controversy?
I would say more lizards from the early Cretaceous and early late Cretaceous.
Yeah.
That's our sweet spot. We need more coastal Aptian Albion into the earliest Cenomanian.
Okay.
Yeah. We need more lizard fossils that are in probably in coastal environments, but just filling out the record of lizards, and I think that would help. And I mean that's always the answer with paleontology. We just need more fossels.
Yeah.
So it's kind of a lame answer, but that kind of targets where if I were going to go to help answer this debate, I would start looking in Cenomanian to Aptian Albion, marine or near marine settings.
Yeah. So that also illustrates a point that I make all the time about paleontology, and that sometimes we fall into the trap of saying, oh, well, paleontology isn't really an experimental science. It's more of a historical science. And I think that's nonsense oftentimes, because you can test hypotheses like that.
Yes, you absolutely can.
You can run experiments by going out and looking for fossils in the field. And
100%.
Sometimes I get the impression that people who say that aren't really field people, you know. It's like,
Yeah.
they've never done this before. Maybe.
I mean, there are plenty of folks doing experiments in the lab related to paleontology as well.
For sure, yeah.
But no, it is an experimental science. We are testing hypotheses out here, and it all starts in the rocks.
Yeah.
In the field.
Is there a particular thing that you would love to find with regard to mosasaurs here in Utah, in the Mancos or Tropic Shale or something like that?
Yeah, so
what's your white whale?
More of those early ones.
Yeah.
So that's one of my motivations as soon as I got this job to chase the Tropic Shale, because it's aged right in the sweet spot, right around the Cenomanian-Turonian boundary and into the Turonian. So about 94-ish million years ago. It's one of the places. Marine, they're already marine at that point,
right?
But it's still gonna help you those marine. There are some other places up near Dino National Monument, the Maori Shale. That's another place I would look. It's a little bit older.
Yeah.
So that's another place I would potentially chase them. Other than that, I mean, gosh, the Mancos higher in section, younger in time, it's not very fossiliferous.
Yeah,
it's tough. I've hiked it many a days and found nothing. We do. One of my volunteers actually, when she was just out hiking around. This is an educator from Salt Lake City, Noreen Kittrick. She discovered a set of mosasaur jaws in a big concretion near Price, and it's mostly weathered out of this big concretion, but you can see molds of the teeth doing this, and so I want to kind of make an actual cast of those teeth within the molds, because it might give us an idea about what it is. My hunch is based on size and where it is in section. It could be Utah's first Tylosaurus. The Mancos does preserve some time where you start to see the diversification of my group of mosasaurs as well. So that would be another thing that would be great to chase. But man, it's just not as fossiliferous as like the Niobrara chalk in Kansas. But they're out there. Somebody's gonna find one. Probably hiking through the Mancos near Green River, and then phone it in. That would be great.
That's gonna be exciting. Yeah. And they've got the man for the job right there in Price. So
exactly. So it would be If you find it, please send it. Let me know. Let me know. Don't pick it up. Take a photo. Take GPS coordinates. Leave it there. I've got a permit. We'll get it.
Yeah. Awesome. That's what I'm always telling Chat too. So how much more
I'll
time
name it after you. Well, since we're good on weather, I'll go to 3.
Okay. Cool. Yeah.
Or however long.
If you've got any other questions, Chad, I'm paying attention now. So type them in.
Yeah.
But maybe we could talk for a minute about marine reptiles.
Okay. Yeah.
And how there's not very many nowadays.
Yeah.
I mean, we're in a world that's dominated by ray fin fishes, cartilaginous fishes, and marine mammals. So like once you have whales and things like that evolving, pinniped, seals, sea lions. Do you think there's just not as much room for marine reptiles anymore?
Yeah, I think a lot of those niches that marine reptiles were filling back during the Mesozoic. You got marine mammals filling those niches now. Whether it's your big macro predators like sperm whales or orcas. Exactly. That's kind of what mosasaurs, ichthyosaurs were doing. Back at that during that time.
Predators,
and then even some of them were very much coastal. Probably hanging out near the shore. Your pinnipeds are kind of filling that niche today. I think much like a lot of our other megafauna on land, those niches are dominated now by mammals. It's the same story in the oceans.
Do you have, speaking of modern marine reptiles, have you got a personal favorite, one that you think is... I certainly do.
Yeah, well, yours is the leatherback. That's a really good question. Whenever anyone asks me what my favorite blank is, I'm like, man, that's something I don't think about as much now that I'm 37 and doing this. Gosh, I do. I mean, I like sea turtles. When I was in Austin during my PhD, my wife and I went down to South Padre Island for my birthday one year because it's in January and it's just cold most of the time, but Padre's usually warm. And they've got a sea turtle rescue there, and
cool.
So I really have a soft spot. The Ridley sea turtle, really big, but I like those Ridley turtles. There are several sea turtle, most sea turtle species I've never seen in the wild, so I'd love to see some.
I've only ever seen a green. And,
yeah.
So far, we'll see after next week.
Yeah. I'm hoping you get out there and get some leatherbacks.
Yeah, absolutely.
But I mean, marine iguanas are kind of fascinating to me.
Yeah.
Because
they're almost on the threshold of between terrestriality and
well,
marine,
they're kind of doing the pinniped thing,
right? Yeah.
Except they're eating veg, and you kind of wonder. That's something else that I think about with Mesozoic marine reptiles. Were there? Were they things like early Mosasauri?
Who's straddling the boundary between terrestriality and being marine?
Exactly.
Yeah.
Or was anything? Was that filled by some weird dinosaur that we don't know?
Sure.
I mean, we've got sniffs of that with Spinosaurids now, but that's one thing I'm curious about. But marine iguanas, I think, are fascinating too.
Are really cool.
Yeah,
I've got a good collection of them at Berkeley, actually, and I've looked at those before in the MVZ, and that's
skeletal, or do they also have some tissue?
They do have some. I didn't look at those. I was just looking at their teeth primarily.
Yeah. Oh, okay.
This is that project I did with Jim on Liaoningsaurus and potential algal grazing. Yeah.
Okay. Cool.
Yeah.
Cool.
Got to get that published. But with regard to marine reptiles, somebody in the chat was talking about, nowadays water tends to be colder than it was during the Mesozoic. But
that's a good point.
How relevant is that really to Mesozoic marine reptiles?
Yeah.
What's their metabolism like? How do we know? What are your thoughts on that?
There's actually some really good information in this book I was looking at. Looking at their bone biology, looking at inside their bone, their histology.
Yeah.
We can tell they were not built, I think this is the one, at least once they're fully adapted for a marine lifestyle, some of them very much, for lack of a better term, were warm-blooded. Physiologically maintaining a higher temperature than the surrounding water. A couple of ways you can do that. You can look at their bone histology, the internal structure of their bone. But one of the really cool you can look at this question too, is by looking at the isotopes, looking at the chemistry of most the other marine reptiles, their bones and their teeth. And when you look at that, you can take let's say a mosasaur and a fish fossil from the same rock unit. Compare the chemistry, usually looking at oxygen. Oxygen 18 versus oxygen 16, two isotopes of oxygen. And your fish probably going to be at water temperature. The mosasaur, if it's at that water temperature, okay, maybe they're more ectothermic, cold-blooded. It turns out most of the time they have an elevated temperature. So the idea is that, yes, some Mesozoic marine reptiles broadly seem to have been endothermic, being able to generate heat themselves, regulate their body temperature really is what they're doing. And then some were at the very least, kind of like leatherback turtles, being what we call inertial homeotherms. Big fancy words there. Basically, we're so big, our temperature is going to stay the same throughout our life, no matter if we go to the Arctic or the Antarctic or anywhere in between.
Sure, yeah.
So yeah, you saw a little bit of that, both of that. So yeah, that would kind of pose the question: would modern oceans support theoretically marine reptiles? And I mean, I think the answer is absolutely. I mean, we know it does, because we have them.
Yep.
But yeah, I think it's more competitive exclusion by mammals.
Why we haven't had big
more
new groups of marine reptiles. There's just a few
Exactly.
cautious little invasions into the ocean by sea snakes, by saltwater crocs, by marine iguanas.
Yeah. And still, those are animals that are and potentially a model for looking at the originations.
Right.
What does that look like very early on in a marine
idea too, like we were talking about yesterday, with live birth versus laying eggs. Developed like live bearing of their young. Why did turtles never do that? Are they the odd one out? Where they don't even seem to be moving anywhere?
Yeah, so this was something I can't remember if it was Pat Holroyd or Chris Bell, my PhD advisor. I was having a conversation with about this. Turtles are also the only group, for the most part. We might find a different one, but broad groups of animals that never, at the very least, evolved gliding. Think about that.
Yeah, no.
And why is that though? Because they've got a shell.
Oh, because our other groups that did, just to set the stage, to to show that it is weird.
Mammals
Have both gliding in things like sugar gliders, flying squirrels, colugos.
evolving multiple times.
Yeah, and we've also got bats, which evolved powered flight. Reptiles, we've got gliding a bunch of times. We've got pterosaurs.
Gliding lizards.
Gliding lizards, part of Squamata, the lizard group.
There are snakes that fall,
Uh-huh.
but
they flatten out the rib
flatten
cage
out
and they
glide.
Yeah.
There are frogs
Uh-huh.
that do that.
Yeah.
So
It's like every major tetrapod group does this, except turtles.
I guess crocs don't, but
Well, birds are
okay,
dinosaur,
well,
and they're
Archosaurs. Archosaurs probably,
Yeah,
but
yeah.
turtles don't. And so I think it's something tied to the shell.
Yeah.
So just like gliding, why can't turtles give live birth? I think it's because of the shell. And it could also just be sort of historical inertia where they've evolved this lifestyle of laying a bunch of eggs, burying them, walking off. 200 million years.
Right.
And they must chicken with it.
Because I don't think there are any modern turtle groups, correct me if I'm wrong, that have any sort of parental care after laying their eggs. Right.
That I can think of.
So they've all got precocial young who just get up and walk as soon as they hatch.
Yeah.
And even groups like Dermachelioids, leatherback turtles, even though they get rid of their bony carapace, at least partway, they still have all of the accoutrement associated with that. Like, they still have their shoulder blades and their pelvis inside of their ribs. Yeah.
So, and that's the one thing, so people think that turtles are weird because, that if you know anatomy, that they're weird because of their shells. Their ribs. Down from their vertebrae like ours do.
Yeah.
Well, ours, because we're vertical, it goes forward. But, if we're forward... and
just like in dinosaurs or other mammals, or what a tetrapod body plan like
exactly.
that.
And turtles are different, though, in that something triggers during development a gene, because I think they have been able to experimentally remove that gene. And it sends the ribs laterally instead, and then they go around the pelvis and the shoulder. So something that's totally different from every other group of vertebrate animals. So it may not be the shell, actually. It may be that ribs encircling all of the girdles and the squishy bits.
And that was just something that turtles evolved really early on, and now it's baked into their body plan. Like, there's no way around it.
Yeah,
no coming back from that.
And also, I kind of wonder, too, because of that, they have a very different way of breathing than most vertebrates. Costal muscles, so the muscles between our ribs. If you like ribs, if you like to that's helping the animal breathe. And because turtles lock their ribs up in their shell, they don't have rib meat, so they're actually breathing by pushing their pelvis up and into, and all of their innards basically into their lungs, which are kind of on the top of the, or just on the bottom surface of the shell.
So just above their plastron?
Yeah, well, so just below their carapace.
Under their carapace. Okay, gotcha.
Yeah. So they're kind of doing that to breathe,
which is,
with their hips.
We were talking about this the other night, which is why, like, people who rehab turtles, people who try to rescue turtles that have been injured or cold struck or whatever, in order to do CPR on them, they'll pump their back legs like that.
Yep.
That's how you do CPR on a turtle. You can't give them chest compressions because they've got the plastron. Yeah. So that's how you do it, and it's interesting to think about. Yeah.
Yeah. So maybe it's also all of that is tied to the shell and the ribs morphology, but it could be because of that breathing motion that I don't know. Yeah.
Really cool. We got another question here.
Cool.
Since I think we have a few minutes. Are there any ideas why mosasaurs went extinct at the end of the Cretaceous while other predators like crocs survived?
Yeah, I think it's a story of were a given group of animals able to, think about air breathing, air breathing organisms. Yeah. Were they able to basically hunker down in freshwater environments? I think. Why do mosasaurs go out and your big crocs don't? Yeah, it could have been the fact that most of them were.
That was a much harder hit than freshwater.
Yeah, absolutely, much harder hit.
So what's the mechanism there? Why did the oceans get hit much harder than freshwater ecosystems on land?
Well,
I know the answer. It's
a big it's kind of a big part of the change in the ocean chemistry for one thing, I really think the weird thing is, to me, is that you have some aquatic animals in freshwater environments that do survive. Yeah. That's kind of the oddball thing to me. But there are other aspects of this too, like big sharks, big fish do fine. Now, granted, they're not air breathing, so they're not having to go up for air.
Oh, I thought a bunch of the big sharks died out at the end of the Cretaceous.
I
could be wrong. I don't.
Good point. I mean, all of the groups kind of survived through.
Yeah.
And I could not tell you what the size curve of sharks looks like across the boundary. That would be a cool question. I'm going to look that up, see if anyone's chased that. But yeah, the other question too, like just in the marine environment, ammonites go extinct. Yeah. Nautiloids don't.
Right. Yeah.
Why? I don't know. Do you have an idea?
Denver Fowler has an idea about it. Yeah.
What is that?
Ontogeny. So that as the ammonites are growing larger, they're moving through different like ecological niches as they grow. Whereas nautiloids, they're actually born fairly large. It's almost like live birth in mammals.
Okay.
And they're just eating detritus like the adults do. And so like you could have a few species that go extinct in a given clade, but the whole clade isn't going to get wiped out like you get with ammonites. Where like they need 8 different niches in order to complete their life cycle.
Yeah.
Nautiloids only need 1.
Interesting.
This is in his Circle of Life talk from like 2013 at SVP.
Oh,
it's cool. I don't think he's published it yet, but he needs to.
Cool.
Yeah. Anyway, I don't know. Correct me if I'm wrong, but I've always heard that the oceans got hit harder than freshwater environments because you just have a total collapse of the food chain in the oceans, where, like, if the sun gets blocked out, you lose the phytoplankton.
Yeah.
And then you lose the zooplankton. And the fishes, and then everything that eats them, all the way up until the biggest mosasaurs.
For sure. The thing is, I wonder how much it gets wiped out, too, though.
Okay.
Because, a pretty recent study. I was talking about this with somebody the other day. It wasn't on stream, so we'll talk about it again if it was you. I've got a colleague who was on a drilling project looking at the impact crater that is tied to the end Cretaceous extinction, and. They drilled the crater, the target rocks. They got in some cases melted, and then but it includes all the sediment afterwards. The plankton comes back quick.
Really?
Within maybe hundreds of years. Now, is that long enough to knock out? And it's the same thing we were talking about earlier. Statistically, did you get the first plankton in your rock core? Probably not. But in the actual rocks, in the target rocks, the plankton and the base of the food chain is back really quick.
Interesting. When you say 100 years is quick, people at home are going to be like, 100 years?
Well, I mean, generationally, all right, everything's going to starve if it's really 100 years or a few hundred, couple thousand years. What is that amongst friends when you're a geologist? But it comes back quick, and that's in the target rock itself, where
that's ground zero.
Where there was probably still hydrothermal activity. Mount Everest hits the planet, it's going to be a nasty place in that spot. But you'd imagine on the other side of the globe, maybe the plankton are doing just fine. Through that interval. So, I mean, that's what I would expect is that, you would have some, was it total collapse? I don't really buy that.
Interesting.
Because,
Okay.
You've still got the fish, you've got the sharks making it through. Doing just fine, and they're not all eating detritus. Like turtles that make it through in freshwater. Do so. It's a complex story because you've also got sea turtles. I mean, the marine turtles that we have in the Cretaceous. Some of them do align with modern sea turtles.
You've got colonioids, right?
In the family tree.
Although you do lose the protostegids, right? So
you lose the
in its skin,
you lose the big ones. And it's kind of a story. Is it the small stuff that survives?
Right.
I don't know. I think saying a total collapse would be a stretch. Was it a bad time? Absolutely.
I'll remember this. I'll make sure I don't repeat that again.
Well, no. I think it's a convention. I'm just. I want to say something controversial.
I like that. I like that a lot.
So and it was a bad day. Dr. Tyler Leeson, single worst day for multicellular life in Earth history. So it was a bad day. It was a bad many generations. But, can we truly say it was total collapse? I don't know.
Interesting.
I don't know. I mean, I'm not saying you're wrong. I don't know.
I appreciate the pushback a little bit.
I just want to take folks through the thought experience.
This is why we're interviewing experts here. Like, I don't know anything about this kind of thing. So
I haven't studied the KPG that much until we started working the North Horn anyway. It was tough. Let's say this. It was enough of an ecological collapse, enough of a bottom-up collapse to knock out everything that it knocked out. So it was enough of one. I wouldn't say total, but it was enough of a collapse. For mosasaurs, plesiosaurs, ammonites to go extinct. But then everything that we see make it through, doing just fine.
Okay.
Cool.
One more question? You got?
Oh yeah, totally. Let's do
it. Let's see. So, Josh, your dissertation looked at mosasaur diversity and late Cretaceous marine. Right?
In part.
What is one finding from that work that you think most people think that you wish more people knew about with regard to that work?
Hopefully not too much more because I haven't published it all. So one thing, that it's probably the next paper I'm going to publish, because I've, after your PhD, sometimes you got to leave your dissertation behind, not think about it for a little while because, it can be a scarring process. That wasn't the case, but, it just so happened, after my PhD, I got a job. COVID happens. I get a new job. start a field program. I just haven't gotten around to publishing those. So most everything that I did is buried. But one thing that I will tell you that will come out in the next paper I do, within that very diverse group, mosasaurines, there's another animal that I'm going to name that the Gnathomortis, and probably half the size, but also has that.
Interesting.
Is that this group that gets very diverse, the mosasaurines, they begin consuming larger prey before they reach large body size. Is there a tie to that? I don't know.
Interesting.
But yeah. So
when we say large size prey, what size are we talking?
So, if you use collared lizards as an example, I mean they can consume things that are just a little bit smaller than that. But this mosasaur that I'm gonna that is written up, I just need to publish, is it's got about a meter long skull. I think based on some back of the envelope calculations I had, I think it would be maybe a 25-foot animal, something like that.
Still pretty big. That's still like orca size.
It's a big animal,
yeah.
But the later ones, later members of that group pushing 50, 55 feet, they get twice as big. But yeah, so I think they start consuming, big food. And then they start getting diverse and disparate, which is another thing I looked at, looking at their disparity through time. So how similar or how different they are.
Right.
And along with that diversity, disparity does increase, at least within that one group of relatively quick. Basically from as essentially one genus around, very by definition low disparity then. Within 3 or 4 million years being is very disparate, almost as much as they are at the very end of the Cretaceous. So that'll be something that'll come out in my next paper. So
look forward to.
So but a lot of the stuff I did is still buried in a dissertation at the University of Texas. But yeah, I think that'll be one thing I'm looking forward to sharing. Yeah, sure, I'm naming new species. Who cares? But, well, a lot of people care. But
that's not what interests you most.
Yeah, no, it's
evolutionary
the
questions.
Yeah, it's the larger evolutionary dynamics. That these new fossils help us tell.
Very cool.
That's what I'm looking forward to.
Yeah. What would you like to plug before we end this? You want anything like that?
Follow the museum. We have Facebook, Instagram, Blue Sky. Just look up the Prehistoric Museum. Don't follow me on social media. It's just all sports and memes. All of my science goes to the museum's account. Facebook, Instagram, Blue Sky. Those are our three.
Nice.
And
Twitch as well. Well,
Twitch.
We already have a Twitch shout out, I'm sure, there in the chat.
Yeah, for sure.
We go.
Yeah, we got Twitch. Once our lab renovation is finished, Matt, who's be running the show when I leave here, he will be streaming live a fossil prep from the lab Fridays 2 to 5 p.m. Mountain Time. That'll ramp back up again once the lab is not a construction zone. But I think we'll probably announce on social media. We might do kind of an update of what the lab is looking like.
Yeah, that'd be really cool.
Here in the coming weeks, especially after field season. But yeah, so check out the Prehistoric Museum. Social media is a good way to figure out to learn about the science that we're doing, the field work we're doing. Supporting the museum. Donations are a big way that we are able to run field work and other research. We're applying for grants, but sometimes those are never guaranteed, and they're few and far between.
Nowadays.
It's rough right now. Check that out. But then also, one of the things I really want to say, because, folks think, all right, we're out here on this dig. It's a nebulous, far-off thing. But, we've got friends out here, volunteers, who don't do this as a day job that come out and get to do this. Mm-hmm. So if you have that passion for paleontology, and if you want to be a part, reach out to me via email, and you can do this too. Essentially, I want to get as many people out into the field, involved with science as possible, because in a way, especially when you have someone who doesn't have a science background, they then become ambassadors.
Absolutely.
For our field. Mm-hmm. But also, it's just a lot of fun. Check us out. And if you're ever driving through Price, Utah, or if you want to make it a destination, come see the Prehistoric Museum. We think it's pretty good.
Awesome. Cool. Thanks, Josh.
Yeah.
Brilliant.
Yeah, thanks for having me.
Yeah.
And thanks for, I know it's your last day here, so thanks for coming out and
of course,
featuring our work.
No, it's been an honor, and I'm looking forward to doing more of this in the future if you'll have me again.
Oh, yeah, absolutely.
Yeah, this has been great.
Sweet.
Thanks, Josh. Cool.
What would you like
and
it
then,
was?
I'll take him back over there.
Cool.
Thank you. And then I'll take the camera back over there, too.
I will be coming back, but next week, or later this week, I guess it's Sunday now, but
yeah,
I'll get some of my gear up.
Nice. Grab those dry erase markers, too, before I forget. But, well, it's not what I was expecting. I thought we'd, get clobbered by that. But so far, so good. I mean, Leah, look. Blue skies on the horizon there.
Yeah, it broke apart just like we needed.
Yeah. There is a chance we could get hit by something from the east or west there, but
everything's moving
north.
So
all right.
We'll be good there.
Nice. All right. Yeah. Beautiful.
A few hours, I think.
Well, I hope you enjoyed that chat. Yeah. And Ms. Blue Sky says, man, it always gets me how cartoonishly Utah some parts of Utah are. They really are, huh? We're actually just outside of Arches National Park, which is there on the horizon. So it is this is an archetypically Utah part of Utah. And I'm going to try not to fall down into the cactus, because my leg is halfway asleep right now. But yeah, we're going to walk around a little bit more, see some other parts of the quarry, answer some questions, all that good stuff. But I'm really glad we get to, because that's, this guy's one of the world authorities on mosasaurs and on turtles, fossil turtles. So, didn't want to miss that opportunity to be able to talk about those critters with him. And I hope you had fun listening. I definitely had fun with that. All right, let's put these things away. I'm going to get some water, too. All right, hang on. Like I said, this is my last stream from the field, probably this year. Probably till 2026. But it's my last stream from this site, at least, for this season. Pretty great. We're gonna keep going for another couple hours, I think. Yeah, let me know if you've got any questions. There we are. Okay. Let's see, how long is the drive home? Asked Deathsaur. It's about 15 hours to get back home to the Bay Area from eastern Utah. I'll be doing that over 2 days, so I'll be stopping in Nevada. And, I could sleep in the car, but I figured I might as well get a hotel, get a shower and everything before I get home. I'm really looking forward to that. It'll be the first shower in, about 11 days? Which is not that much. Earlier this year, I think I went 33 days without a shower when I was in Wyoming. Went through, I can't tell you how many wet wipes, at least trying to stay clean and largely succeeding. But man, you really can't beat a hot show. So yeah, continental breakfast in the morning. No, Claire. Not only does, I don't think the hotel that I booked has that, and even if it does, I'm leaving too early in the morning. I'm leaving before the breakfast starts. I like to hit the road early. Yeah, it's best to get out maybe a little bit before sunrise, if I can. So yeah, that'll be nice. Get back home at a decent hour, and then get ready for. It still looks like there might be a chance I could get involved with a leatherback turtle survey. It looks like that government shutdown might still happen, and if the weather is good, then, well, shoot, that means some of the federal workers who would be working there won't be able to, and I would get to fill in. It would be a tremendous honor. So we'll see if that happens. But just the thought that it's a possibility has, we've been talking all about marine, being able to see the greatest of the marine reptiles, the most quintessentially Mesozoic of today's marine reptiles, the leatherback turtle, Dermachelys coriacea, this most superlative of sea turtles. That would be a dream come true. So we'll see if it happens. Yeah. And supposed to hit the coast Monday, Tuesday, says Hecky for life. What's supposed to hit the coast? Oh, it might be rain when you get back? Yeah. But it might clear up, hopefully Thursday, Friday. I was checking the weather reports earlier. Yeah. But let's check on the shutdown thing. I don't know if it's a good approximation. I have got two sources for trying to figure out if there's going to be a government shutdown happening. One is the news. Checking this on Polymarket. Will the U.S. government shut down by October 1st? 61% chance. It's been bouncing around a bit. But, yeah, that's, we're looking at shapes in clouds right now. We're trying to read the tea leaves, and it's either going to happen or it's not, But this has been one of the ways that I've been, I don't know, being all neurotic over the past week or so. Ever since I heard that I might be able to help fill in during that survey. So yeah. And anywho. We shall see. It is super exciting. Because, do you remember the videos that I was showing of that specialty vessel operated by, it sounds like I'm saying a Bible story, that special vessel operated by Noah. But no, the National Oceanic and Atmospheric Administration. Yeah, like capturing leatherback turtles in a big hoop net and then taking them aboard, weighing them, taking samples, applying tags, doing their vitals, all that stuff, and then re-releasing them with a tracker. That's the crew. They're out there right now. And that's the crew I'd be joining. I almost feel like I don't want to talk about this because I don't want to jinx it, but yeah. Anywho. Anywho, yeah. And winger guarantee. I'll talk about that in a minute. But I think John's getting ready to go, so I should go say goodbye to them. Hang on just a moment. Let me set this down. No proper goodbye.
Probably like get off the stream and get home. Thank you. Oh no, it's pouring there. So they're getting rain too.
Tomorrow morning. tomorrow morning.
Yeah.
Okay,
You taking off, Marcello?
Yeah.
Let's hit our own.
Take care. Yeah, you
Matt,
too.
if you have any questions or need anything, just shoot me a text. So Jacob's going to be pretty close to jacketing.
You're not
over
going
there.
to SVP.
I don't remember how much he's jacking.
Safe travel.
But yeah,
happy
there'll
trails,
be a couple of big
and,
jackets that come out. It'll be nice.
Yeah.
Yep, I'm out.
All right.
Okay. You guys taking off?
Meet a fella.
Oh, that's good.
Yeah,
Yeah.
Michael and I are.
All right.
Yeah.
Yeah, for a second.
Good. Well,
Yeah, it's a pleasure meeting you.
stand up right now.
Oh, it's okay. You're good.
Here.
I'll give you a hug next time.
You gonna put on video, you think?
Yeah, absolutely. Fair enough.
Nice. That'll be cool.
I just have a lot of stuff on me.
More than just Josh. Yeah, exactly. Thanks for coming.
Yes, I'll see you next time.
Yeah, pleasure
Come
having
out
you
and
out.
go
And
clubbing with us.
yeah, I want to go to the Claire. And so you'll be back again. Sweet. I think I put you on my email list. If send me an email would be good because dad brain.
See you in Denver.
Yeah, but thanks for coming out.
Ontogeny.
Oh yeah, that's right. Happy birthday! Thanks for coming out. It's Sunday.
Gotcha.
Thought you could sneak by.
Well, we're not forget now.
Yep.
Enjoy your
All right, I
birthday.
need to remember I always remember it's this time of year because it's always on this trip. 28th of September. All right.
You have to write down all these September birthdays.
Yeah.
Really should. 26,
Yep.
28. All right. Who else? Oh, what's that? 20.
Whoa,
You didn't tell me that. All right.
Dang.
doesn't care.
Well, I was out in the field too, so that's my excuse. Sweet. Happy birthday. I'm putting that in my calendar. Matt.
Or I was like, yeah, I don't know if I should come out right away. The other one, my birthday and her birthday.
I only remembered her birthday being the 25th or something like that.
Yeah.
Is that right? Yeah, because I was like, oh yeah, Matt can't come out because
Those parents
it's
are getting busy.
Late December, yeah. Christmas time.
Baby. Christmas vacation, baby.
And I think our anniversary is
Yeah.
tomorrow.
Oh wow.
Wow.
Nice. No, sorry, I forgot you said your birthday too. I just remembered it was Madeline's.
That was the one on the breakout.
Oh, nice.
That's all I need for the
That's a hell yeah for me.
And that Longhorn is new, so is it good? Is it good? Okay.
Right.
I haven't stopped.
Michael, awesome. Can I give you a hug?
Yes, you can.
All right.
Nice meeting you.
Oh yeah, that sounds great.
Yeah,
San
most
Antonio
likely.
in
Yeah.
October.
Maybe I can convince the boy.
Keep hanging out with Julia.
Maybe.
And
Kenny
yeah,
said
maybe in
he
Denver,
could
maybe
do
out here in
this.
Utah.
Not to
Oh,
GSA,
just
but
do
to the
that.
after.
Yeah.
I'd give you a hug, but you
All right.
haven't been out here long.
So are you guys still going to come
Fair
to
enough.
Price?
Fair enough.
Okay, cool. Yeah. I'll just shoot you a text.
Yeah, shoot me a text, and I'll be back out here on Wednesday.
Okay, cool.
Yeah, if you ever find yourself in the Bay Area, give me a call.
Yeah,
I
right.
always
Make
ask
that a crop top.
Thank you so much.
Yeah,
You
yeah.
know,
Great meeting you.
You
that's
too?
in charge.
Yeah.
So.
Josh?
Yeah.
Danny? I'll see you around. Can I give you a hug?
Yeah, absolutely.
All right.
Give me a hug. I'm a hugger.
Take care.
I miss you
Hell yeah.
guys.
If you're ever in town,
Thanks for
let me know.
coming out.
Thanks for
streaming,
everything. It's been
you know,
great. I really
for
appreciate
advertising
you
this,
that.
you know, for the masses and
Yeah, right. I mean,
people got a kick out of it.
People definitely did. So,
Okay, that's good.
Yeah. And again, if you find yourself in the Bay Area at any point,
Yeah.
just give me a call.
I have a hunch you'll be back here before I see you in the Bay. But yeah, I'm going to take you up on that when I go to Berkeley. Yeah.
And then the fun part.
I'm going to start
That's where the
doing
fun
that.
begins.
Well, guys, y'all have fun.
All right.
Brenda, have a safe.
You too.
There we go. Thank
There we go. Ooh. There we are. Yeah. And Lenny says the camaraderie is so lovely. It really is, yeah. It's good being out here among our people, you know? That's one of my favorite fieldwork. I've said this many times before, and I'll say it again.
One of the best parts of being out here in the field is just being surrounded by people who share your interests and values and enthusiasms, you know? Like being around fellow fossil people, this is my tribe, you know? It's a delight to just be ensconced in that for a few weeks out of the year, 11 weeks in my case this year. It's been a joy. And being able to share a little bit of that with you, I think is really important also. You know, not to be too lofty about it, but it's important to show that part of science, I think. The human side of it, you know? I think all too often science is seen as some sort of arcane ivory tower, you know, something that's not accessible to regular people, and scientists are somehow less human than everybody else, and not in the field I work in. I can tell you that. I've not worked in other scientific fields, not really, but I can tell you paleontology has some of the coolest people around, some of the most fun people to hang out with. It's a good time, and being part of a crew like this where we're all working toward the same goal, we're all helping each other out, just coming together as a team. That's really nice, you know? I wish everybody had the opportunity to experience this kind of thing. And many people do with other things, whether it's social groups or, you know, whatever. Nice to have something like that. And if you, any of you at home don't have that, I know that's the stereotype for Twitch viewers, is that maybe they spend a little bit too much time on the computer. Might be true in some cases. And it might be a challenge sometimes to go out and find a group of people to spend time with. It's really nourishing, though, if you have the opportunity to do that. Yeah, even if you're not particularly social or, don't have a lot of opportunities to go out and try that kind of thing, if you make the effort, it can be really rewarding. So anyway. Enough of this. Oh, we've got a beautiful lizard right there with a long tail, all kinds of black spots. Here, let's see if we can get a little closer. It is right there. See where I'm pointing? Sneak up. Are you a leopard lizard? What are you? Are you a collared lizard? You're beautiful. Who are you right there? Oh, man, you're fast. My goodness. Look at you, friend. What are you? I might have to take a screenshot and post you to iNaturalist later. But you are beautiful. Almost gecko-like in your skin texture. Who are you, friend? Wow. Hi there, pal. A good day? I'm having a good day. Sorry we're making so much noise over here in your home. You know, these folks will be gone in about a week and a half. I'll be gone tomorrow morning, so we won't have to worry about me trudging around up here anymore. But, you are beautiful. Look at you. Very nice. So this is a relic that we were talking about earlier. So it's also a squamate, a lizard. So those giant sea reptiles evolved from something not too different from who you're seeing right now. Wow. Kind of magical, right? Man, I love lizards. Yeah.
Yeah, it does look like gecko skin, right, Claire? Yeah. Holy cow. Hope somebody clipped that. Lovely. That's another wonderful part of being out here in the field is just being out immersed in nature. You know, I got here not this past Friday, which was my birthday, but the Friday before. Got here on the 19th, and part of me wishes I could be out here for another 2 weeks. But it's going to be really nice to go home. Anywho, being out here in the desert is pretty special too, you know. Just, you know, being immersed in daylight all throughout the day, and then when the sun goes down, you know, it's like your body just starts to realize, like, oh shoot, it's time to go to bed soon. The sun is going down. There's not blue light distracting you all the time, messing with your internal clock. You know, your body's kind of attuned to, you know, sunrise and sunset, daylight and nighttime. There's something invigorating about that. I feel like I always sleep better when I'm out in the field. I don't know what it is, but being outdoors all day, doing physical labor, thinking, talking, socializing with folks, you know, at the end of the day, you feel like you've really earned that good night's sleep. And I always sleep well in the field, better than I do at home, you know. And I've got a big comfy bed at home. I don't have that out here. I have a cot, which is nice. But, yeah, I don't know. Something about just being out here in the field, it's not something that you might imagine a scientist saying, but it's kind of magical, you know? Anywho, yeah. And do you stay in the desert overnight? Absolutely, Spaceberry, yeah. I'm camping out here, yeah. And yes, the landlords, the Moon Pie, Mini Pie, and Sweetie Pie will be very happy to have me at home, all three of the cats. Yeah. Here, let's go check out the quarry. And, yeah, it's going to be a bit quieter here without Josh. That's for sure. But let's go have a poke around real quick and see what's going on. We'll start over there at that side of the quarry with the big bones. Oh, there's our lizard friend again. And then we'll move into the other site, the other quarry. And oh, and shoot, before I do this, if anybody happens to be new watching right now, I'm sure there's a few people, maybe some lurkers, people who haven't said anything in the chat, but they're just tuning in. Let me first give you a quick background on what we're digging up here. We kind of jumped right into that interview with Josh, so didn't have a chance to really do that spiel at the beginning of stream and talk about, you know, what we're digging up here and why it's important and all that background stuff. So we're here in the early Cretaceous Cedar Mountain Formation. These rocks you see behind me are about 130 million years old, give or take. Our date for this quarry here is about 132 million years old. Although, yeah, sometimes these dating methods can be a tad imprecise, so that's not a hard and fast number, but that's our best approximation at the moment. About 132 million years old. So this is the early Cretaceous period. This is about the same time when the first flowers evolve. So up until this point in Earth history, flowers were not a thing. They did not exist anywhere. They had not evolved yet. And flowering plants, the angiosperms, include everything from like fruit trees to grasses. So imagine a world without grass. That's funny. There actually wasn't any grass until after the dinosaurs anyway, pretty much. So, but there were no flowers at this point in all of Earth history until right now, the early Cretaceous period, about 130 million years ago. The dinosaur in particular that we're digging up here is called Gastonia, and in these two pits here, we've got over 40 specimens of this animal, 40 individuals, and this is just the tip of the iceberg. Here, this is Gastonia right here, so four-legged armored dinosaur, what we call an ankylosaur, and this is Gastonia burgei right here, which is not the same species we have from this site. This, I think, is actually the type locality for Gastonia lori-mcwinnii. So here's Gastonia burgei here, top view showing the arrangement of the armor plates, what we call osteoderms along the body. And then here it is for Gastonia lori-mcwinnii. We think this is maybe about 5 million years younger, something like that. But, and lori-mcwinnii could be a direct descendant of burgei. We're still figuring some of this stuff out. But if it is a direct descendant, it shows that these animals are getting spikier over time. These big spiky plates running down the tail are even longer, sharper, pointier than they were 5 million years prior. So, yeah, really, really cool animal. And I'll show you a plastic model of what this critter may have looked like in life. Here we go, that I got especially for this trip into the field. Behold Gastonia right here. So this animal would be about 15 feet long in life. Yeah, so about the size of like a small pickup. And yeah, about 5 meters. So protected animal, not only with those armor plates, but with all those sharp spikes as well. Not the sort of critter you'd want to try and tackle in a fight. And we think that's probably why they evolved all of this armor, was to defend themselves against predatory dinosaurs. Things kind of similar to Utahraptor, things kind of similar to like Acrocanthosaurus, big two-legged meat-eating dinosaur. So, yeah. Let me grab my laser pointer in order to point to some things in the quarry without having to get too close. There we go. So, yeah, this site was first discovered in the 90s. It was, back then it was being worked by the Denver Museum of Nature and Science. Their team came out here in the 1990s and they were looking around for fossils, trying to find new sites. And a lady by the name of lori-mcwinnii discovered this site in, I think, like the late 90s, something like that. And, yeah, she found some ankylosaur armor plates and some bones sticking out of the ground. And then the crew came over and dug in, and we've got 2 main pits right now that we're working that are kind of continuations of their digging. These got reopened in 2023 by the Prehistoric Museum that Josh is curator of. And it's actually tied to the Walking with Dinosaurs TV series that just came out this summer. So apparently the BBC, the British Broadcasting Corporation, they were contacting some people in England, like Susie Maidmont, and saying, hey, you know, we want to do an episode of the new Walking with Dinosaurs reboot or whatever. We want to do one on armored dinosaurs, but we want to send a camera crew out to record some paleontologists digging up armored dinosaurs. And I think it was maybe Susie Maidmont that they reached out to. And she said, well, you should really contact Jim Kirkland in Utah. He's got a bunch of armored dinosaur sites. And so Jim said, well, we've got this one incredible site out there in eastern Utah that nobody's worked for a while. Maybe we can get Dr. Josh Lively to reopen that quarry, and that way you can feature it in your documentary. And Josh has said, yeah, okay, that sounds good. It was... It's funny how these things work. Sometimes you just need a little bit of an excuse to restart some field work like that. And this is one of... It is the most prolific ankylosaur site in the world. There are ankylosaur bones everywhere else on the planet. And so Josh is like, yeah, that sounds great for the museum. Featured in the documentary. And that was 2023 that they filmed that. It just premiered now in 2025. I was supposed to come out in here and help for that, but apparently they signed a contract with the BBC, so there couldn't be any other media on site, and I guess that also carries over to Twitch, too. So now that it's finally premiered, I can be here. Now that contract is up, and yeah. And I'll show you some of these bones. And I am thankful too, Golganek. I finally got to be here. It's funny, I came out here before they reopened the quarry in 2023 with Jim, and we collected some sediment samples to try and get some zircons to get a better date on the site, and that's how they came up with the 132 number. So I was here before they even reopened it, but didn't get to stream from here. Go ahead. Yeah. Sorry, Brenda. Here we go. So I've been showing this off a lot, but do it again. And every day there's just more bones to show off. It's pretty impressive.
Oh.
So to start with, here is that one of these big armor spikes right here. I love showing this off because it's just so charismatic looking. But here's where it attaches to the animal. There's the pointy end right there.
Here's a nice one.
Yeah. Oh, and you go, oh, beautiful. Holy cow, Heather, look at that. That is really big. That's nuts. Wow, I've not seen this yet. And you've got what looks like a nice phalanx next to it, too, like a toe bone?
Yep.
Nice. Excellent. Very, very cool. How long ago did this get found? A few days ago?
No, today.
Today? You just... That's why I haven't seen it yet.
Yeah.
Awesome.
Yeah.
A birthday spike.
Yep.
Happy birthday, Heather.
Thank you.
Really exciting.
Very
Holy cow.
Working in silence.
Yeah.
I know.
Yeah. Shoot, I guess work quietly and carry a big spike.
Yeah. Pretty much.
Very nice. That is truly impressive. So again, I'll point to the outline of it right there. The tip is missing. It looks like an ancient break right there. So that happened back during the Cretaceous. But yeah, look at that. Nuts. So cool. That's got to be one of the big ones coming off the side of the tail, I presume. But I'm guessing.
Yeah, I think that's what Matt said.
Yeah? Awesome. Yeah, very cool. Nice. See, it's just new things all the time here. It's amazing. Yeah. And is it a splate? I don't know if that's what Jim calls a splate. Plates might be up near the neck. We can look behind me. But as you can see, there's just bones everywhere. We've got a rib right here. Another one right there. We've got a limb bone right here. We've got all kinds of ossicles, osteoderms all over the place. Just truly impressive. Here's that hip bone again, what could very well be an ischium right here. There's a limb bone. Just... It's not often that we say that there's too many bones. Like, that's not normally something that we complain about as paleontologists. It almost feels ungrateful to say that. But here it does make things truly difficult because you'll be trying to dig around a bone and then you just encounter more and more and more bones. So trying to dig a trench around them is exceedingly difficult. So, you know, over here where Brenda and Julia are working, you could just, it's just a crazy pavement of bones. I mean, look at this. So you've been trying to dig a trench through
I
there?
had to go, and this popped up, so I had to like stick to this side and just let that be.
Oh man.
Because it was just there, like right across
Right.
it.
Nut.
It's impossible to bypass.
So you just can't dig a clear trench through any of this without hitting bone?
Yeah, and I'm not doing that because I'm leaving tomorrow morning. But
Right.
I am gonna try. I'm trying to clean it up a little bit, and this part up here still has some siltstone and stuff that I'm trying to work through. So
That's pretty incredible.
yeah,
Shoot.
it's a lot.
Yeah. Should we do a little shout out for your program at DMNS?
Sure. Yeah.
Yeah, so Julia and Brenda here both work at the Denver Museum of Nature and Science, which is the museum that initially opened this quarry back in the 90s.
I wasn't there though.
Yeah.
Because I was 0. I was negative something.
But
Yeah.
what do you two do at the museum?
So we are both educators at the museum. So we teach programs at schools and in the museum to students who are on field trips. We do work in galleries. We do virtual classes. We do community events. It's like all across the board community outreach.
That's cool. That's
really
really
fun.
important. I mean,
It is. If you're not talking about it and
Exactly.
sharing it.
Yeah. Yeah.
Yeah, and it's, I mean, I'm a paleo person, but just having more experience in the field helps us to be better at teaching people about what
Absolutely,
they're
yeah.
seeing. So.
And you can tell kids, they ask you, oh, what's it like being on a dinosaur dig? And you say, well, I just came from that last week, Let me
Right,
tell
and
you.
they often, they'll be like, have you ever dug up? I'm like, yeah, and they're like, really? You have? Like, yeah, I have. And I
You're
do.
meeting a celebrity. It's like,
Right, they're like, wait a second. No way. Yeah. We teach like all sorts of things. Any kind of science you can think of, basically, we have some kind of program for.
That's so cool.
Yeah.
How can people follow or you know
Well,
see what you're doing? Yeah.
Great point. So we also, part of our like sporadic things that we'll do, we do TikToks. So,
Okay, yeah.
So you can see our faces in some of the TikToks at the end.
Nice. Yeah.
we're frequently in them. I think
Denver M&S.
Yeah,
Yeah?
Denver M&S on TikTok. It's pretty funny.
We'll get some links in the chat.
Yeah.
Very cool.
Woohoo.
Yeah. Well, thank you.
Yeah.
And holy cow, just I can see.
Yeah, wish us luck, everybody. This is never gonna end. So.
What's nuts is like you just have this crazy dense, pavement of bones like this. And
Yeah.
as I understand it, this should continue into the hill for
Yeah. I know.
like
I was gonna.
2 acres.
I was gonna try to trench this way, and then there's a big bone that's going in there.
Just
I don't know
right
if you
there?
can even
Yeah.
see, but like right there, there's something going in
Oh man.
the hill. So I'm not going anywhere
Mm-hmm.
with that. This is also a beautiful one. I've been admiring. I don't really know what that is.
Oh yeah. Wow.
When
We have a nice-
started, this was
A nice one over here.
Looks almost like a
was,
humerus.
over
Yeah.
here.
Yeah.
And then we moved everything a foot back so we could like go around this. And when we moved everything a foot back, this popped up, that popped up, the one that Julia has over there popped up. So maybe a foot wasn't enough, but
Yeah, maybe we need to.
But
I'm not moving
we're
it back
gonna
further
work with
today because there's no
Right.
time, but probably it will need to be moved back again.
Man. Oh, this will be somebody else's problem.
Yes.
Starting tomorrow. I was digging over there. Yeah.
Yeah.
Anyway, very cool. We've got a link to that TikTok
Follow us.
in the chat.
Yes, please follow Deanna.
Cool stuff. Yeah. Thanks so much.
Yeah.
Here, let's go take a look at that diagram and see if I can figure out where the where are the splates? And somebody was asking how many ankylosaurs do we have at this site? So the super conservative answer is 40 individuals, and that's like the absolute minimum number. So like you have to find, when you have a bunch of animals that all got disarticulated, the bones got scattered everywhere. There's just bits and pieces of everybody in every place. How do you estimate how many animals you have there? It's like, imagine you have, a whole bunch of different cars and they all get torn apart in a junkyard. And the pieces are just scattered around. How many cars you've got? Well, what you try and do is find only one per car. Like, say, steering wheels. I don't know. Most cars don't have more than one steering wheel, right? You could count the number of steering wheels, and then that gives you a rough approximation of how many cars are there in the junkyard. Would that make sense? Here, they did that with the basioccipital. So with the occipital condyle, that's the ball-like projection that comes off the back of the skull. It looks like a trailer ball, and that's what attaches the skull to the neck. And so by counting the number of those that they found, they said, we've got 40 so far of these animals. But there's almost certainly more. And that's only in the area that we've dug so far, both through the Denver Museum and through the Prehistoric Museum now, from the 90s, and then the last 3 years here. So there's one pit there, but it seems like this entire hillside here, if we were to dig down to that horizon, we'd find more of this. Because every time this kind of dinosaur, they're just everywhere. There could be hundreds, could be 1,000, could be wild. Again, the most dense accumulation of ankylosaur bones anywhere in the world. It's truly extraordinary. And is that Auntie Kathy there in the chat? Yeah, Quiddy. Hello, Auntie Kathy. I hope you're good to see you. This is my last day streaming here in the field. I'm going to leave tomorrow morning and head on back home to California. I've got some other exciting stuff coming up that I've got to get ready for. So it'll be a little bittersweet leaving tomorrow, but yeah. I'm excited to be home, too. This is my 11th week doing field work. My 11th week this year digging dinosaurs. That's a record for me. I've never
never done more than like probably 8 or 9 weeks before, even in the busiest of years. So this is, you know, I've done a lot of field work and streamed nearly every day in the field. What, 11 weeks? Translate that to days, that's what, like 77 days? Have I streamed 77 days in the field so far? Something like that. That's pretty impressive, you know? That's like, what, 1/6 of the whole year? Something like that? I don't know about that, but yeah. It's like a huge herd, says Samurai. Yeah. It's interesting. We're trying to figure out how this many dinosaurs got buried in the same place. And we've got some ideas. I can talk about that in a minute. But, yeah, again, extraordinary sight. And Luke Herman's Gaming says, do you think that there were weather types in the past that don't exist today? For example, tornadoes exist in very specific areas in the world by very specific events. Perhaps change of climate, shaping of land and seas that change streams, different layers of atmosphere. We do know for a fact that there are certain kinds of, I guess, meteorological effects. Like, I don't know. Things like super glaciers we don't have today on most continents. You get big glaciers in Antarctica. I think the biggest ones in the world are in Antarctica, the great southern continent. And we get some up in the Arctic as well, and in some northerly areas in North America and Asia and Europe. But you don't have the kinds of super glaciers that existed just a few, tens of thousands of years ago, maybe hundreds of thousands of years ago back in the Pleistocene. So back then, you had like areas of the northern Midwest in the United States, places like Chicago, where there was ice a mile thick. I think it's a mile. I might be exaggerating. You can look it up. But we don't have anything like that today, and there surely would have been really interesting weather phenomena that occurred back then that we just don't get today, At the same time, you would have had, I don't know, if you think about way back in the Triassic period, when all of Earth's continents had all bumped into each other, drifting around, they'd all, kind of converged on one side of the planet into this giant landmass we call Pangaea. There in the center of Pangaea, you would have had really arid desert climates, and there must have been incredible sandstorms and things like that at different points in time during the heyday of Pangaea. Stuff that, maybe we can barely imagine. And then on the other side of the planet, away from Pangaea in Panthalassa, all ocean, it's like one side of the globe is just water, Maybe there are a few scattered islands here or there, I don't know. Yeah, it's one half of the planet, ocean. Think of the storms that may have formed in those areas, the massive hurricanes and things like that. Surely there were weather phenomena that we can scarcely fathom. I'm not an expert in this kind of thing, but I'm sure if we were to talk to some paleogeographers, yeah, they'd be able to tell us some pretty interesting stuff about that. I don't know enough about this kind of thing, I work on dinosaurs. So yeah. And let's see. And the Laurentide ice sheet was up to 2 miles thick. Holy cow. 2 miles is like 12,000 feet almost. 11,000 feet, something like that. That's nuts. Holy cow. Captain Rob's Adventures, how are you doing? Welcome to Paleontologizing. It's a nice partner badge you got there. Welcome. It's good to have you here. Yeah. Yeah. Let's go take a look at the other side of the quarry, too, and talk about how we may have had so many ankylosaurs all preserved in the same spot. You saw how densely packed the bones are over there. Over here, they're not quite as densely packed, but they are large. Tells us some interesting things, potentially. Michael Chiappone, who is our, resident taphonomist, he just left a few minutes ago. But that's been his big project here at this site, is not just digging, but trying to figure out what can we infer from how the bones are arranged, from the lithology of the rock, from these different like weird signatures that we see here in the strata? Yeah, we talked with him a few times about that. Sorry we can't do that right now. But he's trying to decipher like what in the world happened here in order to get so many of these armored dinosaurs all buried in the same spot. And we've got some ideas that make sense right now, but I don't know, as we continue to dig here and gather data, that story could change. First, let's just have a quick poke around. We haven't dug as deep, so these bones here, just by virtue of the erosion, these are closer to the surface. So they're not in as good shape. Like, they tend to be a lot more crumbly. The rock here has been eroded further, so it's very dusty. You know, this isn't really like bedrock anymore. It's been weathered to the point where it's fallen apart, and some of the bones are falling apart too, more so than over there. But we've again got bones just all over the place here. Not quite as densely packed, but really nice bones here and here. There's bone there and there and there. What looks like a vertebra right there. Be right here too. Some sort of a limb bone or a rib right here and here and here. A bunch of these were exposed by the students from Birmingham who were here earlier in the week. They were just digging in, uncovering things left and right. And now it's going to be this crew's job to collect these things, to actually safely get them out of the ground for the next couple weeks. Yeah, I'm not going to be able to help with that because I leave tomorrow morning. But they've got their work cut out for them. Holy cow. We've got a nice vertebra right here. This looks like an osteoderm, an armor plate. Got another here. Another one right there. Some sort of big limb bone. Could be a tibia or something right here. Could be a femur. Not totally sure. Rib right there. Just all over the place. And again, the bones over here seem to be bigger. That's going to be important later. We'll talk about that. Yeah. So, how are you guys doing over here?
Not too bad. How are you?
Doing well. Here's Matt. He's the lab and collections manager at the Prehistoric Museum. Here, I can shade your eyes from the sun with the shadow.
Thank you. So much better.
But yeah, and was it your idea to start the Twitch channel?
Mm-hmm.
That's really cool. Yeah. Awesome.
Yeah, we were also doing YouTube, but wasn't many people there. So.
Exactly. Yeah, I'm gonna do my best to try and direct more people toward your channel because it's so cool for people to be able to see the work in the lab.
Yeah.
And I'll have to ask Josh when you guys are going to be starting those streams up again. And
I'm gonna do like an update stream to try to show people the progress on the lab. But it'll probably be a little bit later after that.
Yeah.
Just with how delayed things have become with
Of
the
course,
lab,
yeah. But you've got a really exciting new big renovation going on. Tell us about that briefly, if you don't mind.
Yeah, so the renovation, basically the plan was to just completely update the lab.
Mm-hmm.
So it's all, the equipment we use is, relatively up to date, but it's mostly the infrastructure itself. So
Gotcha.
cabinetry, tables, the floor even.
The things that people don't think of very often, yeah.
Dust extraction, air compressor, and lines,
Nice,
and all
okay.
that stuff.
Yeah.
So it's basically all new cabinets, basically new epoxied floor.
Nice.
Well, epoxied floor.
It was just concrete before.
Ignore the cracks in it.
Yeah.
And we're getting new tables.
Nice.
We are getting like a packing table, basically like a collections prep table.
Yeah.
And we ended up getting a fixture from Joann's when they went out of business. That we're going to put things like Tyvek and felt and Ethafoam, holding all that stuff.
R.I.P. Joanne, but at least we were able to benefit from that.
Yeah, exactly. Worked out for us.
Yeah.
We have new dust extraction going in. The lines are already in. The extractor
Nice.
is in. We have to hook up the arms still.
Uh-huh.
The air lines are in. We just have to move the compressor into position.
Nice.
And
That's so cool. And so you designed all of this too, right?
Mhm.
Like, I mean...
Yeah, and doing most of it too. So.
And you're doing the actual work as well. Yeah. But that's really cool that, like, Because this is a fairly new job for you, right? You just started in the last few years?
Yeah, basically just over a year.
Oh, nice.
There,
Okay.
yeah, so.
And you get to like design and produce a new level.
Yeah,
That's
yeah.
really, really cool. Just like organize everything according to your preferences.
Yep, yeah.
Pretty awesome.
Yeah,
Oh, man.
whenever basically I got hired on, Josh was like, think of it as a blank space.
Nice.
And so I was like, all right, I'm gonna redesign this, and
Right.
and then it was just a matter of getting the funds. So.
And we have some idea of how particular you are about certain things, like the pencils and
Yeah.
coffee and everything else. So
Uh-huh,
that's going to be really, really cool to be
yeah,
able to
yeah.
have everything just perfect.
Yeah, exactly. So
I'm excited for you. That's really cool, and I'm excited for that stream too. It's gonna be neat.
I'm excited.
Yeah. Thanks, man.
We'll get there. Yeah, thank you.
Yeah. So you can see we've got some larger bones right here too. Here, I'm gonna be obnoxious and use the laser pointer right here. Right there in front of Jacob. But yeah, so he's working on pedestaling around some of these bones. We've got looks like a rib right there. So they can make a smaller jacket. He's probably gonna try and dig a trench between that existing jacket. And nice.
Yeah, we're gonna before we really go at it with a trench.
Yeah.
This is an area where we had some of our so far just isolated little pieces of theropod bone pop out. So
Yeah.
we're trying to be really careful with this one, with anything that we're doing in this area.
Gotcha. Because if there's more theropod bone, like it's most likely to be.
If it's under here, we
Yeah,
don't want
yeah.
to accidentally destroy it with
Uh-huh.
the trench.
Nice. Yeah. And then what do you got going on over here, Connor?
Trenching, brother.
Yeah, nice.
But I'm just making it deeper and wider because this just scares me.
Yeah, for sure.
I'm a first timer and there's a bunch of bones right here and I don't know, man. So just deeper and wider. That's my strat right now.
Yeah. You say you're a first timer, but you've got a lot of experience in geological science.
Yeah, ore deposits. It's a lot different than dino bones, but
Yeah.
you know, if it's not grown by a farmer, we're pulling it out of the ground, right? So,
Yeah.
but this is more fun.
Yeah. It's good to have you out here. It was really cool, like listening to your banter earlier about mining geology and all of this stuff.
Oh,
That's a world
yeah.
that's completely foreign to me.
Oh yeah,
So-
well this stuff's foreign to me too, so you know.
Yeah. Well, I don't tend to think of this stuff as being particularly difficult, but
I don't know, man. Like, I see bones, and that's why we're out here, and how fragile they are, and I'm just like, you know, I don't want to get invited again.
I think there's a pretty good chance of you coming back if you want to. So.
All right, sweet.
Yeah.
Cheers.
So yeah, let me know if you've got any other questions, Chad. I'm gonna go get some water.
Shout out Whitney Cleaves if she's in the stream. Or
Oh, I haven't seen Whitney yet, but yeah, shoot.
We miss Whitney.
Yeah, I really wish she could have come out this time. She was out with us in Wyoming back in June,
Oh wow.
and we were collecting plants for her and everything. That was super cool. But yeah. I'll let you know if she pops up in the chat. I'll come back and let you say hi.
Oh yes.
Yeah, awesome. Thanks, Jacob. Oh, here we've got a completed jacket. I guess just needs to be labeled. Brought back to the laboratory. So the lab, Matt is going to open this thing up. So he'll take a cast cutter saw, and he'll presumably go around here, just around that pie crust part around the top, lift off the lid, and then start chipping away the rock. With chemical consolidants like PVA glue and stuff, and just making sure that these bones can be placed safely on a museum shelf without crumbling. Also, they can be studied and photographed and published on, and we can use those to try and understand, what this animal was like when it was alive. Gastonia lori-mcwinniae. A big part of what we're doing here at this site too. Let me show you that. And Wookie, here, let me show you the temperature right now. Let me grab the thermometer. I'm curious too. It was hot earlier. It's cooled down a little bit. But right now, okay, 84 degrees Fahrenheit, 31% humidity. That's higher than I've seen almost this whole time out here. Yeah, 84 Fahrenheit. It's actually pretty cool. it's usually in the 90s during the day. So, clouds have really helped. We had some nice shade early and late enough in the day that the sun is starting to move lower toward the horizon, and it's just not going to be as intense, which is nice for us. Yeah. And hey, happy New Year. How are you doing? Welcome, welcome. Good to have you here. Yeah. So yeah, 29 degrees Celsius. Thank you, Charlie's Dragon. Excellent. Yeah. And nice to see how the jackets I've been working on have come into existence as Happy Nightmares. There you go, yeah. So you're doing some work in a prep lab, right? This is how they, how those jackets get constructed in the field. So, yeah. This is, is made, to use a very non-vegetarian analogy. This site, and Michael already took off, so we can't bug him about this, but I can give you a rough little spiel on some of this stuff. So again, like, how in the world do you get all of these bones accumulated in the same place? The rocks themselves offer a lot of clues in this. So this rock right here, what we call the matrix, which is what surrounds the bones, this is a nice kind of almost greenish paleosol. So I'll see if I can find a chunk for there. There you go. Really fine grained. So you break that apart in your fingers, and you see how small the particles are. They're almost like dust. So very, very fine sandstone. We think this is like a sandy soil, essentially, out on a floodplain. We know there's big rivers nearby because we get these big channel sands out here. That's some of that. It's all these environment, lots of flowing water. But then here, this is not the same kind of environment. This, but mixed into this, among those really fine-grained particles, you get a bunch of pebbles, like right here. You see all these? This is very unusual. It's noteworthy, and that's really important. Because this shows us that this is what we call poorly sorted. So like not all the grain sizes are the same. You get really, really fine-grained sand, and then you get these weird pebbles showing up too. So what's going on there? Well, I'm kind of paraphrasing what Michael has said every time we've had him on stream for the past week. So I'm going to do my best here. I'm not a taphonomist by training, but here's what I've picked up. This tells us that these particles are flowing water. And so all of these bones that are deposited here too may have been... the arrangement of these pebbles here not only tells us that there was flowing water, but it can tell us the direction of flow. And it could potentially tell us also how much energy there is. So how fast the water is flowing, how much power is behind it like that. That's really important to study. And so Michael was saying that he thinks that the water flow is coming in this direction because of how the pebbles are arranged. They're kind of collecting along, you know, bones. So they're concentrating where you get these little like safe spots almost behind the bones. They weren't fossils yet. So the pebbles can accumulate right there as the water is flowing over. And it's almost like a windbreak or something like that, if that analogy makes sense to you. But yeah, again, why pebbles mixed in with this? Michael's starting to think that this may have been like a levee break or maybe an overbank deposit. So again, we've got rivers all over the place through here. Sometimes you get, if you get torrential rain and the river fills up, it can overflood its banks. Or if there's sort of a levee situation there where the banks of the river are raised up, and they kind of like keep the river from flowing out onto the floodplain. Sometimes those riverbanks bust open, the levee breaks, and then you just get that river that's able to flow out over the floodplain, and it'll be carrying a lot of material with it. A lot of sediment, pebbles like that. So that's what he suspects is going on here, and it makes a lot of sense. So that can explain how the bones got buried, but here's the thing, if that flash flood, that river overflowing its banks, if that's what killed these dinosaurs, then their skeletons would still be together. If the same thing that killed them is the same thing that buried them, you know, if they died in a flash flood event like this, you would expect them to get buried whole and to have all of their bones. That's exactly what we don't find here. Instead, the bones are all scattered around. Some of them are broken. Skeletons were already here on the surface before they got buried and already got scattered around. So there is, for whatever reason, a big accumulation of armored dinosaurs that all came to the same place. They died here. Their carcasses rotted, maybe got scavenged. The bones all fell apart, got scattered, and then later they were buried by that river overflowing its banks. And so our tentative story right now, the thing that seems to fit best with the evidence we have at the moment, it's all tentative, it could change when we get more information, but our story right now is that these animals may have died in a drought. That explains a few things. It explains why we have so many dinosaurs here in the same place. Because if they're all coming down to the river to try and get water, that's what can concentrate them all in the same place. Up during a particularly bad drought, if there's just no water to be had, they could starve or die of, and then you just have a whole bunch of armored dinosaurs, all of these Gastonia, that all, and then later, when the rains come, they're already there, the bones all scattered around, just ready to get buried. When the rain finally comes back in force and that river gets super high, overtops its banks, dumps sediment onto them. That's our current story that we're working with at the moment. All of this could change if we find some information that contradicts that. But that's how science works, you know? We use the information that we have, we form the most plausible explanation, the one that fits the data the best. But sometimes you get new data and you have to rethink things, you know? Science is often tentative in that way. It's because that's the thing. We're not just trying to come up with a good story. We're trying to figure out what's really true, you know? If we only wanted a good story, then we'd come up with a good story and leave it at that. That's not how science works. Science is about following the evidence where it leads. Science using data that you collect. To do here. And so that's why we can't say, oh, this is definitely how it happened. Because this, you know, this is 130 million years ago. And we've only excavated a small part of this enormous site so far. There could be more information that could change that story. We'll see. So I hope that makes sense. Yeah. And, you know, not to disparage that Walking with Dinosaurs episode that features this site. But, yeah, the story that they have there is, it doesn't match the data that we're seeing. A forest fire and quicksand, that's not the story of this site. No. Yeah. But yeah. And let's see. And hey, Flickster, I will drink some water in a minute. But first, Ann Wookie's got a question. What's the coldest place you've ever worked in? Like, ever actually excavated fossils in? That would probably have to be... Let's see. The summer, or maybe the late spring, or the early fall here in Utah. This is not the coldest place. I guess maybe Wyoming. In fact, this year in Wyoming may have been the coldest fossil fieldwork I've ever done. Because on a few days, it dropped down to like 30 degrees, something like that. If it had started to rain, it wouldn't have been rain, it would have been snow. We're up there at like 7,000 feet elevation. It's pretty high up. And when those Wyoming winds whip through, it gets chilly. At night, I think it dropped down to about 20 for a few of those nights. So yeah, that's probably the coldest place I've worked so far. But
yeah, with any luck, it won't be for long. I'd love to be able to work in some places like Antarctica. We'll see. That's a dream of mine. Maybe someday it'll come true, but yeah, let me go get some water. Would be wild. There are a good number of dinosaur fossils from Antarctica. It's still in number 7 if you were to rank all the different continents for how many different dinosaur fossils have been found on each. Antarctica would still be last. It's not an easy place to work, but there are dinosaurs from Antarctica. They were first discovered there, I think, in like the 70s or 80s. You had the first dinosaur named from Antarctica, and I think the late 80s or early 90s. Cryolophosaurus ellioti, that's from Antarctica. And then you have Glacialosaurus, you've got Emperobator, you've got a new kind of ornithopod dinosaur that I've got some friends working on, which I'm excited about. I even heard what the name is going to be, and I can't tell you, but it will be exciting. I'm really looking forward to when that thing gets published. I don't know, and Antarctica is just, I've talked about this before on stream, but that is the dream of so many different scientists, is to work on the great southern continent, Antarctica, you know, a continent for science, I've heard it described as, where most of the people working in Antarctica are there for scientific reasons, you know, whether they're on research bases or whether they're, you know, as working as scientists doing research, or whether they're that makes all of that happen. It's like just about everybody who goes to Antarctica goes there for science, and it's a place, from what I understand, never having been, but you know, I've read different accounts, I've seen documentaries and stuff, and actually I can share this. I think you might enjoy this too, chat. I forget exactly what show it was that, what was the title of the series that Anthony Bourdain did? It was like a food and culture host. He's a chef by training. But down to Antarctica and talked a little bit about the food, which, you know, all of the food they bring in. But it, you know, that was almost an excuse just to go down there. And it's like that whole episode is almost like a love letter to science. I thought it was really cool, you know. I think you'd enjoy it too, if that sounds interesting to you. One of the best celebrations of science that I've seen in a long time, from a guy who is like a chef and a TV host and like food journalist, food writer. I thought it was pretty cool, you know? Yeah. And anywho, it was good stuff. I don't think it was no reservations. I think it was parted up, and even give the episode number, my IMDb link, because I'm sure it's on there. Yeah. But yeah, he seemed like a neat guy. I agree, Claire. You know, I've read some of his stuff, and like, I don't always enjoy it. I don't know if I would have gotten along with him personally. Just like, I probably would have, but I don't know. Very different values in some ways between me and him. But man, do I appreciate that episode that he did about Antarctica. It would have been cool to have some conversations with him, you know? Just be able to tell him, hey, that was some of the best television I've ever seen. Truly. Like, well done. Yeah. Yeah, I don't know if he would have liked me. He famously despised vegetarians. But I don't know. You never know. There you go. Thank you, Claire. There's the link there. Hang on, let's get some more water. I don't want to die of thirst like may have happened to these Gastonia.
Casey Snowart says you could convert him to a more favorable opinion of vegetarians, I bet. Maybe. That's a neat thought. Yeah, man, that breeze is nice. Oh. It's funny, you know, this is I brought both of my field hats out to this site. I haven't worn the sun helmet at all. We're kind of on the threshold between sun helmet and digger hat. There were definitely moments during this trip that I wished I'd brought the sun helmet out of my tent instead of this leather thing. Yeah, that is much better for hotter temperatures. This is better for milder temperatures. But it's nice when you can just take it off and get the breeze through your hair and just cool off a little bit. How are you doing, by the way, Casey Snowart? It's good to see you. I'm looking forward to fixing my 3D printer when I get home. Because one of them's on the fritz. I've got two. My older one is having a thermal runaway error again. I think I might need to replace the thermistor again, twice in a year now. But I want to get started printing that vaquita for you, so I can on and you can bring home a dolphin, porpoise rather. Oh, and clearly he has softened. That's cool, Yar. I did not know that. Okay, nice. Yeah. Just relaxing for the week ahead. Lots of TwitchCon prep. I haven't even started on that. Shoot, it's probably too late for me to order stickers unless I get them rush produced. But I might do more pinback buttons again, because I can produce those myself. Make those by hand with my button press. So I might be doing that. Yeah. And Wookie, who said I was vegetarian? Who told you? That's supposed to be a secret. No, I try not to make a big deal out of that. But yeah, I don't eat meat. I've been vegetarian since December of 2011, which is a while. And yeah, I don't know. Lots of different reasons. I don't want to make a big deal about that though. You are too. Very nice, Anwookie. Cool. Yeah. Don't tell the carnivores. I don't want them to get any ideas. That actually became a thing in 2012 when I was working out in the Judith River Formation, northern Montana. We were just a few miles south of the Canadian border there, and we had a lot of carnivores on that crew. And I was a newly minted vegetarian then, and some of these paleontologists and Liz Friedman Fowler, there were a few times when in the quarry they would have very animated conversations about what would happen if we got stranded in camp, if the roads got rained on too much, if we couldn't get out, if we ran out of food, about how they were going to carve me up. Saying, well, Danny, you're a vegetarian now. You're lower on the trophic web. You're going to have, you know, fewer heavy metals in your flesh. Yeah. It's almost like you're grass-fed. Very involved discussions about what I would taste like, where the best cuts of meat would be, everything else. And I'm just trying to make myself very small on the other side of the quarry. And Crimson Knights has just stumbled across this channel. Wonderful that you're doing this. Thank you. Hey, I really appreciate that. Yeah, I was planning to be out here for a little bit longer, for like a full 2 weeks, but some things came up and we didn't end up getting that front page slot on Twitch like I was hoping to on October 1st. So we're going to be leaving a bit early, going back home to California. So this is our last stream from out here at this site. This is day, 10 or 11 of digging? But yeah, let me know if you've got any questions. This is the best way that I know of for doing science outreach. I want to show you firsthand what it's like to excavate fossils, to do paleontology in the field, and it's a tremendous privilege. And let me know if you got any questions. Yeah. Appreciate that Crimsonite, rather. My sister's husband is a paleontologist. Oh, very cool. Neat. There's a decent chance I know him, actually. You don't have to say his name if you don't want to, but if you said where he worked or whatever. Yeah, it's a small world, especially invertebrate paleontology. Those of us who study critters with bones. There's our big annual conference that we have every year, the Society of Vertebrate Paleontology meeting. It's in Birmingham, UK this year. I'll be attending. Very excited. But it's such a small... some of the people organizing that conference... Here just a few... And Richard Butler. Yeah, cool talking to them about SVP, talking about their research. Got them on camera a few times. It was neat, but yeah, it is a small world in fossil science, for certain. Yeah. They have to keep you around, Danny, because they know you won't eat them. There you go, Luis de Leon. Good point. He works out of Texas. Oh, cool. We've got some Texas paleontologists and paleo people here in the quarry right now, actually. In fact, let's go over and say hi to Erica. I don't think we've featured her on today's stream yet. So let's go bug Erica for a second. See what she's working on. But yeah, she's coming to us from Austin, Texas.
Oh.
Erica.
No problem.
But yeah, what do you got going on over here?
I switched spots.
Uh-huh.
I kind of got tired of working on that.
Yeah, sometimes you have to do that just to preserve.
And extracting is going to be hard because we're out of gypsona.
Oh, we are.
We're very close to being done, so we
Yeah.
want to conserve it.
Uh-huh.
And I think I'm going to go into town tomorrow and maybe get something else to try and
Okay, nice.
use to flip that because it's very thin.
Uh-huh.
And if I
You're
flip
talking
it,
about this spike right here?
yeah, that nice spike right
Yeah,
there.
yeah.
Yeah. So anyways, left that and started working over here.
Mm-hmm.
And I think what I'm going to do is just try to even this out here.
Nice, okay.
Because there's some good stuff happening
Yeah,
right here
there's a
that's
bunch
all
there.
90 degrees to itself, but this is a real nicely preserved bone.
Look at that.
Then there's this conglomeration over here too that's interesting. This one's broken off in half, so
Yeah.
you know, you pick a spot and have fresh eyes.
Yep, that's important. Yeah. You had somebody in the chat mention a relative of an acquaintance. I forget the exact, but they're a paleontologist in Texas.
Yeah.
Why is Texas a hot spot for paleo stuff?
Oh, Texas has a really rich history of
Yeah.
paleontological specimens. We see it all the way from the Permian, before there were dinosaurs. Everything was just an amphibian eating each other, and then all the way into the Cretaceous, and then into the mammals as well. So we've got a little bit of many slices of the history of time because of Texas's really rich variety of geological formations. So if you've got interest in paleontology, you know, UT Austin has two tremendous labs. They've got an amazing non-vert paleo collection. So everything that doesn't have a backbone, so plants and invertebrates, even modern shells and things like that. They also have minerals, 4 million specimens. And then we have about 2 million specimens at the vertebrate. And we have an enormous modern library as well, which is unique because then you can compare modern specimens, things that recently died. Tens of million years old, but still are very, very comparable. And it's just an incredible resource with it.
Very cool.
Yeah.
So.
And Austin's pretty cool. Food's really good. There's a lot of fun stuff.
Good music and.
Pretty good music.
Yeah.
There's, you know, a lot of sports and stuff. So yeah, good place to come.
Yeah, and you're gonna have a performance at some point. You were saying
Oh my
too.
God.
Do you want to
So
talk
you're
about that?
outing me. Okay, yeah, sure. I'll talk about it.
If you want to, you don't have
yeah,
to.
obviously I have no problem talking.
Yeah.
So I've been in a Iron Maiden cover band for, God only knows, like 20 years.
Uh-huh.
And we've taken a hiatus recently, but we're going to have our 25-year reunion
Oh, wow.
on January 31st at Come and Take It Live in Austin, Texas.
Nice.
So if you want to see me, pretend that I'm Bruce Dickinson, jump all around the stage, probably get injured. It's going to be a wild time.
That's
We're going to
gonna
have
be
a
really cool.
Judas Priest tribute and a Thin Lizzy tribute.
Uh-huh.
It's going to be rocking.
What's the name of the band?
We are called Drifter.
Drifter.
Yes.
That's a cool name.
It's a song from the very old Iron Maiden. So thanks for the shout out. If anybody's interested in
Yeah.
heavy metal, come see me. Be cleaner than I am now. Because it's pretty bad.
I'm looking forward to getting clean for the next couple
Oh
days.
my God,
too. Holy
dude.
cow, that shower tomorrow night is going to be really, really nice.
I'm wicked jealous. I got another week and a half to go.
Yeah, well, if
so-
you're going into town, you could go to a truck stop or something and get a shower
Well, I
potentially.
could.
Yeah.
But will I, though?
Yeah, that's the thing is I had that chance in Wyoming too. I went like 33 days without a shower, I think, this year.
Okay.
Yeah.
All right.
And it's like I could have gotten a shower halfway through, but that almost just kind of like breaks the magic or something. It's like, I don't know. I don't want to go soft halfway through the field season, you know?
Yeah, you kind of get out of that mode, that
Yeah.
feral dirt person mode.
Exactly.
Which is really important because it can be tough to be out here.
Yeah.
But it's also awesome.
And you're going to be out here for the next, what, like
I
week
leave
and a
on,
half?
Yes, I leave on the 7th of October.
Very nice. So yeah, here for the whole stretch. Here
Yep.
first night, all
First
the way
night, close the quarry, we'll go home broken. And then I will eat a lot of enchiladas. Iron Maiden songs in January, so
through. Very cool. Looking forward to that for you.
Thanks, Dan.
Yeah. Thanks, Erica.
I got it.
Here, let me go get some more water too, before I forget. But yeah. And how do I find the schedule for the concert? I'm sure you could just look it up. I don't know if there's going to be an official thing, but I don't know. Yeah. Yeah, she's a tough cookie. Absolutely, Just Blue. Yeah. And are all the students going to be there as long as well? No, I think he's here for the entire dig. Even Josh just went home. Left, what, a couple hours ago. So yeah, Erica might be the only one here for the duration, which is pretty cool. Man, that smells like rain. Getting a little bit of this from over there. You can see a little bit of rain. That's not going to hit us. It's all going north. But you can just feel that. You can feel the humidity. Let's get our humidity meter out and see what reading it gives us. "43%. I knew I felt a difference. My goodness. That is wild. That is, yeah, much less humid. Much more humid, rather, than we're used to. I think we got down to like the lowest so far, the past couple weeks. Which, even that feels humid compared to what it was when we were over at Doling's Bowl last month. That was very, very dry. I think we got down to like, what was it, 4%, 3% humidity at one point. One of the driest places I have ever been. We're getting into monsoon season here finally, so there's a bit more moisture in the air. There's a lot more rain going on here and there. Yeah, and man, it feels good. Almost feels like home in a way. So it's appropriate. It's gonna make me homesick, and then I leave tomorrow morning to go home, so it's gonna be nice. Temperature dropped 10 degrees. Oh yeah, 74, exactly, Flickster, yeah. Good stuff. That's a big change in such a short time. Yeah, Deathsaurus, it's like that. The deserts are kind of famous for having abrupt temperature changes. That's why, you could, whether it's daytime or nighttime, respectively. Environment that's this extreme, yeah, there's not a lot about it that's particularly hospitable, I guess. You know, I say this all the time, but just look at the plants that we have here. What plants we do have? We have ephedra. We've got these little bunch grasses or something like that. We've got sagebrush. We have whatever this thing is. I'm not even sure what this guy is. I should iNaturalist that. See what that thing is. But everything is adapted, especially evolved to live in such an arid climate. So surviving with no rain, hardly any moisture at all for large parts of the year, but it also has to be able to withstand torrential rain. So, you know, the plant. Of course, we have our classic cactus. I think these are prickly pear here. They're not blooming right now, but when they do, they've got these and very, very temporary. They bloom for, what, like a day or two out of the year, and that's it. The rest of the really spiky, sharp, hardy little plants. And of course, we've got, here's one that's caught on this sagebrush. But let's send that away, shall we? That might be a non-native plant. That might be, was it Russian thistle or something? We have another one right here. Ugh. There we go. Yeah, that Edward Abbey talks about in his book Desert Solitaire. He wrote that when, well, it's about his experiences being a park ranger at Arches National Park before it was a national park, when it was still a national monument. But there's a certain kind of beauty in a harsh desert environment like this. It makes you appreciate every living thing that you see because it's able to eke out a living in a spot that's difficult to survive in. This is not a nurturing place. So anybody who can make it out here, you know, there's something special about that. You know what I mean? Yeah. Great book, by the way. I'm thoroughly enjoying it. Eat it right there, says Jonesy. There you go. I could. Yeah. Wily plants. Yeah, and Bozocentric agrees. Yeah, I'm enjoying it. I haven't had a whole lot of time for reading here, honestly. I think I got like 50 or 60 pages into the book. But, yeah, we have so much work to do and so much socializing and cooking and camp life that, you know, I can read a few pages in the morning and that's pretty much it for the day. That, and I've also started reading a book about leatherback turtles, too. At the same time, I got 2 books going at once. But I also downloaded both of them as audiobooks, so I might be listening to both as I journey back home to California over the next 2 days. It's going to be good. And Just Floof says, imagine how tough plants are in the Sahara with just what little grows there. It's cool to think about, for sure. And who's snoring so loudly in the background, says Luke Herman's Gaming. That's the wind there. It's a bit windy. There's not really trees to show you how windy it is, but this could give you some indication. Whatever this little plant is. And Ann Wilkie says, I have this Western movie tuned in my head looking at this landscape. Yeah. It's something. It really is. I'm going to be a little bit sad to leave it, but I'm also excited to go home. And Just Floof says, would this be more of a tundra kind of desert since there's more for the plants to hold on to? I guess. It's not like we've got shifting sand dunes here. There are parts of Utah that do have that. But no, this is a rocky kind of desert. And it does snow here during the winter as well. So it's not, you know, your archetypical, always hot all the time, sand everywhere sort of desert. This is a desert, I think, in the sense that we just do not get a lot of rain here. And what rain does fall happens during a pretty short span during the year. It's just a very dry place. And we're also altitude, but we're at what, like, I think we're at like 4,000, 4,500, maybe 5,000 feet elevation here. I think it's like 4,500. So, yeah, that'll be, what, 1,100 meters elevation, something like that, above sea level. Certainly not on the coastline here. Although what's funny is this area over the Natarita Formation. Well, you get the Natarita up there, that sandstone at the top of that. That is all like coastline sediment up there. So that's river deltas, estuaries. You know, this big blocky sand that we have today was all deposited by flowing water right out, going out to the ocean. So this was the coastline. This was sea level at the time that those rocks were deposited. And over the past 120, 130 million years, you've had a tremendous amount of uplift, you know? This part of Utah used to be sea level, 0 elevation. Now we're at 4,500 feet. A lot can happen in 100 million years and change. It's cool to think about. And there you go, Crimson Carnotaurus, this is true. Can't remember your name. What was it? Was it Donnie? Denny? Is that it? When we get out of the desert, I'll remember. Daryl? That doesn't sound right. There you go, RB42, yeah. Anyhow. But yeah, let me know if you've got any other questions. How do you wrap up a field season like this one? Given that this is our last stream here, I've had a really good time here. It's cool to get to know a new crew. You know, see the different ways that they do things, because everybody's different. Everybody uses slightly different tools. They have a slightly different approach to digging and data collection and setting up camp, you know, making meals, that kind of thing. I can talk a little bit about how this has been different from my other field experiences that I've had. Because I've been digging dinosaurs nearly every summer since 2011. I actually calculated this out in my head last night, or maybe the night before. If different field sites count as different field seasons, so like us working out here for a week or two, if that's a different field season, then I've done about, I think this is my 21st field season. My 21st jaunt out into the field, I'll put it that way. So I've done a good amount of field work. First field work I did was when I was like 19, and I'm not 19 anymore. But like I said, each crew does things a little bit differently. You've got different people on it with different experiences, different priorities, different budgets, different situations. One of the things that I've really appreciated about this crew is just kind of how informal things are. Josh's approach is, people are showing up to volunteer. They're taking time out of their busy lives to come out here and dig up dinosaurs and collect data and survive out here in the desert. You know, give people leeway to kind of do what they want, you know. You can redirect them if what they're doing isn't productive. But, yeah, one of the things that Josh says is, like, people are working hard out here. We're translating calories into bones excavated. So feed those people well. And we have been very well fed. Hot breakfast every morning is something that I'm not accustomed to in the field. It takes a lot of effort, but just about every morning Josh has been getting up early and cooking breakfast for everybody on the griddle. So sandwiches with eggs to pancakes. We had pancakes with crumbled up Oreos in them a couple days ago. I'd never seen that before. but that'll give you some calories for the rest of the day. It's been really nice having hot breakfasts, and rather than packing a lunch and bringing it to the quarry and just having a quick lunch break, Josh is like, no, let's go walk back to camp and make our lunches together and sit around for a little bit and talk and just relax a little bit during the middle of the day, and then go back to the quarry and work until it's time for, to wrap things up for the day. That's been kind of nice, having a break in the middle of the day like that. It does seem to kind of make the day go by faster. Normally how it's worked out is we get back from lunch and it's time for me to start my stream. So, yeah, it definitely makes the days go by more quickly. And it works well for this crew and for Josh's management style. Dinners have been really good as well. Yeah. On every field crew that I've worked on, except for a couple, we've had like a hot meal at the end of the day. Only a couple times have we had like cold canned food, and those tended to be much shorter field seasons. If you're going to be out here in the middle of the desert with a bunch of people for a long time, you have to feed them well. You have to have at least one hot meal per day, and here we get 2, which it's been really nice. Yeah. And I'm not used to this style of digging, too. It took some getting accustomed to at the beginning, where we just have so many bones that are so densely packed. Just trying to trench around them is a challenge. And so the work does have kind of a slower pace here because we have such a density of fossil material. That's been interesting getting used to also. Yeah. Oreo, everything. There you go, Luke Hermans. Yeah. Does it feel more guided, less fending for yourself at mealtime? No, there's more fending for yourself. So there are much more like lunch offerings here, and you just kind of like, if you want to make yourself 3 different sandwiches, go ahead, you know? Other crews that I've been on, it's like, nope, we got to ration the bread, we got to plan things out. It's a bit more open-ended here. Choose your own adventure. And it works for this crew, and it works for Josh's management style. So, yeah. Good stuff. Yeah. And, yeah, but generally, I think part of what seems very different about this whole trip into the field as well is that the lighting is different. It's a different season. We're late in the season. It's autumn already, and I'm not used to doing field work during the autumn. So the sun rises later and sets earlier. The days feel shorter as a result because the daylight is shorter. It kind of makes it feel like things go more quickly in a way. And it's not better or worse. It's just different. And it's cool that I've experienced that now. Someday, maybe if I'm working in Antarctica or up in the Arctic, near either one of Earth's north-south poles, that might be 24-hour daytime. That would be really wild to get used to. Even just this small changes, it's so different from what I'm used to in a field season. Nearly all of my field work has been like mid-May through maybe mid-August. Have something at the end of September feels very different to me, and I'm glad. I'm excited to move on to even weirder, wilder things in the future. Greater latitudes, north or south. Yeah. But yeah. Anywho, we're coming up on 3 hours here pretty soon, and I'm gonna have to go to the bathroom. Drinking a lot of water, and I also want to make sure that I get a little bit more digging in before I have to leave for the season, because this is it. I'm taking off tomorrow morning, and I won't be back to the site for. Josh said maybe they'll open it up in the spring. Maybe I'll be here for that, or maybe I won't. Maybe I'll be off doing other things. But I want to make sure I can do a little bit more digging before, before I gotta take off over the horizon tomorrow morning. Hit the road again. Take the Prius back on home to California. This is it until 2026. A long winter of not being in the fields as Geeks Tour. Yeah, but it's also going to go by real quick for me. Holy cow, we've got exciting things coming up. We've got TwitchCon in, what, like 3 weeks now? I got to get ready for that. After TwitchCon, we've got... I'm going to be gone probably without streaming for like 2 weeks. Going to the UK, meeting with other paleontologists, visiting fossil sites and museums and stuff. It's going to be a lot of professional development. I'm excited for that, and I'll try and still share stuff with you even if I can't stream. Maybe we'll finally get into the Twitch Stories thing on mobile. See about that. Figure out that sort of thing. And then we're going to be having a bunch of different special events, interviews with other paleontologists. Operation Leatherback will be continuing as we continue to learn about leatherback turtles and interview experts on them, and maybe do some IRL live streams here and there. I'm excited for what this autumn is going to bring, and oh man, I got a lot on my plate. I also have a lot of science to work on. Been talking with Josh about different research projects to do, papers to write, illustrations. There's a lot to look forward to, and man, I can't wait. So I'm really glad you could join me for this chat. It's been really good streaming from here. I'm gonna miss this place, but I'm also excited to get home. So yeah, let's go ahead and try and find somebody to raid. And Schulp? I'm not sure, Luke Hermans. We'll see. Not sure who that is. Yeah. Famous Dutch paleontologist. Yeah, I don't know, Luke. We shall see. Let's see who... Oh, and hey, Moohoodles. How are you doing? Welcome, welcome. I'm glad we were able to raid into you the other day. That was after our... we had a bit of a wind disaster here, but the tarps all blew over. I saw you did that astronaut interview, right? Not just with somebody from NASA, but with a real astronaut. That was pretty cool. If anybody's not yet following Moohoodles, you're missing out. Go give her a follow right now. If you like space science, astronomy, it's cool stuff. And Moo, I'm looking forward to seeing you at TwitchCon again this year. It's going to be really good. Always love catching your field streams. Thank you, Moohoodles. Yeah, it's been really good being here in your home state, in Utah, for the past 2 weeks. And but I'm also excited to get back home. I've got exciting things coming up there too. So, yeah. And Volcano Doc just popped up. Well. Hello to you too, Volcano Doc. Are you going to be at TwitchCon this year? I know you've got a big, exciting, fancy job in the world of academia right now. Kind of a dream job, I hear. It can be difficult to tear yourself away from that to go to TwitchCon. So, we'll see. Volcano Doc went live. Well, that sounds good. Well, let's go say hello to Volcano Doc, I suppose. There we go. There's Volcano Doc. Okay. We might have to wait a minute until Volcano Doc actually appears on the screen. But we're going to jump in there while she's doing her stream starting soon screen. And maybe I'll delay for a minute or two here. Maybe I'll stall. Any closing thoughts for being out here in the field? In the Cedar Mountain Formation, eastern Utah, Lori site. It's really cool to finally be able to stream from here now that media embargo is over. Now that the Walking with Dinosaurs episode finally aired. I was hoping to stream from here in 2023, and legally it didn't work out. It's good to finally be able to do that. It's really nice to be able to showcase another institution some more friends and colleagues. Cool to be able to collect specimens for the Prehistoric Museum in Price, Utah. And I'm looking forward to seeing what they do with these fossils, all the research that's going to come out of this, and the displays, the public outreach. Josh is doing some really exciting things at that institution, and I'm really proud to help promote that in our own small way here through these streams. And I know people made contributions to the museum via their donate page, or just following their Twitch channel and stuff like that. All of this makes a difference. And I'm hoping that some folks who watched us doing fieldwork here this past year, or the past 2 weeks, I hope that some of those folks might even come out and help out with some of these excavations this museum is doing next year in 2026. There's lots of different ways that you can get involved in paleontology, and fieldwork is one of the most exciting. I hope I've sufficiently made the case that you can do this kind of thing. This is make important contributions as an amateur, as somebody with no formal education in this discipline. You can still come out cutting edge of science, make important discoveries, collect important data, just our growing understanding of the history of life on Earth. It's so cool to be able to do that, and it's very possible. You at home can do this. So I hope I've gotten that point across over the past couple weeks, streaming from here. And I know that we've made at least a small contribution to the success of this research project and the success of this museum as a whole. I'm really proud of that. It makes me happy. It's been an honor, It's been an honor to show you this and to answer your questions, and yeah. It's been real good. I'm grateful. Filled with gratitude, overflowing. Vexy says, wishing there were opportunities like this in Europe? There are. There are field crews in Germany, in Italy, in Portugal, in Spain. There are places where you can go do, and that's just in terms of dinosaurs. I don't even know what opportunities exist if you're interested in digging up fossil mammals, fossil amphibians, the Cenozoic and Paleozoic stuff. I'm not even aware of the stuff that exists out there, how you can get involved, what you can do, but I'm sure there's stuff to do. Look into it, because we all need volunteer labor. We're operating on small budgets. We need the help. So that's the bread and butter of paleontological fieldwork, that's so important. The volunteer work that we can get, Yeah. Anywho, Coathley says, thank you for explaining. You bet. Oh, wait, no, never mind. Hang on. I'm talking to Claire. Anyway, that's probably long enough. Let's see if we can go right into raid volcano dock. There we go. Excellent. That'll be really good. Volcano Doc is a real-life volcanologist, a volcano scientist. And she's going to be talking, and get ready to learn. There's so many cool people doing science on Twitch nowadays, and that list is growing. It's pretty cool. Again, it's been such an honor to stream to you from this site. Big thanks to Josh and the Prehistoric Museum. They're doing exciting things, so keep an eye on that institution. There's going to be some cool fossils being prepped, displayed, new papers coming out, new critters being named, and we'll try and cover that as much as we can in the next, in the coming months and years as these things are unveiled. And thank you so much to everybody who watched today, who watched throughout the last 2 weeks. Thank you to everybody who supports these streams financially and makes it possible for me to come out here and do this sort of field work and stream it live. Again, it is a big privilege, and I'm deeply, deeply grateful. Moderators too, who keep this a safe and welcoming community for everybody, and help me do tougher without you mods. Holy cow. And I wouldn't be quite as cheery, certainly, on these streams. Thanks for making it easy on me. Yeah. With that said, we'll raid out, and I will see you again next in California, everybody. Not sure when that'll be, but we'll find out. All right. Oh, and we already raided in. I missed it. Well, let's end the stream right here.